Hey, see us there, that is only one office. Sorry, sir.
Yeah, she is 1-0.
Start intense.
When she was leaving, then we went for some Delhi one. And that was the last. Yeah. The mother of the
Yes, her father.
there.
Yes, so like 1 month or so.
Just joined and she has to name.
This is what people see.
Because after that happened, she was all like, hey, you should have it work from
Yes, yes.
she will take off.
Can you just turn it off
She
again?
was there for 2 months, then she got a job from home. So I studied in IAS and now I'm at WRM. Vinam. Yeah.
Yeah.
Sir, this not they were yesterday went to Bombay. They came yesterday, but today some guests came. So they whenever we host here, last time he came, they also tried to.
She had interviewed him for one of the
Yeah, there was an interview at IIS.
alumni.
I was the presenter for that, so it went very well. I was hoping.
He would have came, suddenly in the morning only he called and said,
It's live. Everything you say is now recorded. Recording? Recording and live also. Streaming also. You can wait 5 minutes.
We can wait.
I think there might be some
whatever he said, he will come.
Only this.
Come a little bit back.
Sure.
I want to put in 2 times.
Speaker won't come, no? See that.
Then you are saying,
Yeah.
What will you do like for 30 minutes?
then we can start talking.
Yes.
2 minutes we can start. Start. And last is it.
Santhosh, say everyone to come friend.
See, if somebody wants to see clearly the screen.
Yeah,
then
you
see
can come,
the
friend.
Okay. Now seats are active.
Screen won't be visible in last.
That screen might be visible in the source of QGIS. Like transparent. If you want.
Go. What's your name? Raju. Oh. So, Raj Bhagat I told. Yeah. Okay. Ready, Bhagat? Dropping.
Working good. Testing. All my photo dummies for the next time.
Usually people come at half an hour late. But it is expect around 70 registered. So around 50%. Oh, Raj. Where is yours? Keep checking it.
I didn't get any link.
Made a post. You made a post to stream.
Yes, yes.
Come on, Slack. In Slack you check.
No, on WhatsApp.
Send in WhatsApp.
But just keep checking, that's it.
You should start then.
Wait, bro, wait. Also mention we are also streaming live, so that say whatever you speak, speak wisely. Tell everyone.
Sure.
Say.
When you started, we have to stream.
Before also you have to say already you are streaming, bro.
It's not trying to stream. I'm saying.
Yes, I think we will start.
Checking the stream, so they're waiting for it. Just you can see people are waiting for checking the stream.
So we will start like just 2 minutes.
We are waiting for the stream.
Bro, you are live, bro.
So people are saying, we are waiting. Just we are crossing the stream, so we are waiting for minutes and then we will start.
Hello everyone, we are waiting for like 2 minutes, checking the live stream, we will go on.
Why this lagging is little bit? Whatever is moving, it is not continuous.
No, but after staying पूरा कंप्लीट होने का प्रोसेस and then we share again. We'll start.
Hello, hi. Good day. It's my pleasure to welcome you all to this Let's Talk Spatial 7th event. We are meeting here in Satyukt again. The first meetup was in Satyukt, like we are the 7th, and you taking time in the Sunday morning to come and attend this meeting. It's really happy for us. And I'm Santhosh, a co-organizer in the Let's Talk Spatial, and we have Aman, Amrut, and Thiyaku, who's also from the organizing team. I will just give a brief overview of what is Let's Talk Spatial, and then we will carry forward this meeting. So Let's Talk Spatial community, we just started on the goal to bring experts from different domain, from both industry and academy, and then make them like share their knowledge with the audience. So we thought of having this every month, so we will keep this running. And this is inspired from the old Geo Bangalore group and also the Geo Pune. So we are doing it for the past 7 months, and Today we are having Bhagat and Ujaval as the speakers. We also have a website where you can check more information about Let's Talk Spatial. Here you can find about previous talks and also the future talks. So do follow this website. And also we are having the YouTube page. We recently started it and we are recording. This meeting is also recorded and everything is live streamed. And we are also having a GitHub page. So here you can find all other information who is speaking. We will keep this updated. And also we have a Slack group. If you are interested in joining the community, do join. There we have channels like technical development. So here we have other channels which you can use it. We are having resources. If you find any resource, you can put into this. Community people can use it. And if you have any questions you want to ask, it's like a general forum for geospatial people where you can come and engage in it. So this is Let's Talk Spatial. And we are thankful to the Satyukt Analytics for having us again here. So first meeting we just had like 20 people and like we started, and 7 months back we are thankful to the Satyukt team and Sat sir for having us here. I would like to welcome Thiyaku to speak something about Satyukt.
I think mic is not good. Hope everybody can hear me. Right? Yeah. Mic. Okay.
Oh, yeah.
Hello. Fine.
Yes.
Yeah. So, welcome everyone to Satyukt Analytics. Okay. We founded, just a quick intro about what we do. We founded in 2018. We are an agri-tech company. We majorly works on agriculture related works, on water resources and risk management. And we do mostly everything using open source like QGIS or Python or GRAS. This is what we do. And let the talk, take the major time from the speakers. We have two good speakers. Let them talk. If you have any questions, anything to know about Satyukt, you can ask me. Okay. And second, welcome to Satyukt. You have bathroom over here, washroom, and drinking water is available at that backside corner. If any queries, please. Thank you.
Thank you, Thiyaku. So today regarding the meetup, so we have decided on the theme as water. This is to recognize the importance of the International Day of Action for Rivers. So this day is celebrated, or it is on the March 14th. This is to bring an importance to the conservation and preservation of rivers and water. Conservation and preservation of waters in this geospatial industry plays a major role, as everyone here from the geospatial industry, at least once in your life you would have done water classification. So we want to show the importance and make this theme as water resource management this time. And we have two already well-known speakers. One is Mr. Ujaval Gandhi and other is Mr. Bhagat. They are going to speak on from the geospatial industry how we can use it for water conservations. I will introduce I will invite Mr. Ujaval Gandhi. So Ujaval Gandhi is a renowned geospatial technology expert and the founder of Spatial Thoughts. He left his job at Google, where he is an early employee and served as a lead trainer in Google Earth Engine India. He pursues passion to sharing knowledge. He is a world-renowned training facilitator whose materials are used over 100 universities and over 1 million users globally. Today he will be presenting on the topic automating geospatial analysis with QGIS, a case study of processing rain gauge stations for the hydrological application. We are honored to have you here, sir. Please.
Hello. Hello everyone. Thank you for inviting here. Really nice to be here in Bangalore and be among the geospatial community. Apologize in advance for my voice. I'll try to speak a little louder, but otherwise please bear with me. I want to talk about QGIS today. This is, I've been working with the QGIS community for a long time. It's one of the nicest open source community that's out there. So I want to show some tools in QGIS and how you can use QGIS for processing rain gauge station data. This project that I'm going to talk about, it came from a project that I worked on a few years back and used QGIS exclusively to do some hydraulic applications. I'm going to skip the intro. Today we're going to talk about QGIS and how you can leverage QGIS for automation. Everything that you need to, everything I'm showing is open source. All the data sources, all the stuff, all the code, it's all linked from the slide deck. The only link you need to note down is shown on the screen here. So if you note down the bit.ly link, you'll have access to the presentation, which contains links to all the other stuff. Right? And then you'll be able to replicate what I did today. And if you want to follow along, there are step-by-step instructions that you can do this. If you're watching this on the live stream, welcome. The same applies here. Do just note down this link, the bit.ly link, which will get you to this presentation, which contains all the link. I'll spend about an hour talking through the various ways you can use QGIS for automation, starting from a very lightweight automation using the desktop GUI, and then taking whatever you did and automating further. So we'll talk about this problem of calculating aerial mean rainfall from rain gauge data. We'll start with some data, do some data cleaning, and we'll say, how do I solve this problem? We'll first solve it using the desktop tools. We'll just say, solve each step, see the result. Once we are happy with the result, we'll say, now can I just build a workflow? And QGIS comes with the workflow tool, so we'll use that to build a workflow and then automate our pipeline. Once we said this is great, now can I run this without me being present? Can I run this as part of a pipeline? So then I'll show you there are built-in tools which allow you to take your workflow and run it on the command line. So QGIS comes with a command line tool, we'll use that to say, now I have a workflow, I have the data sources, can I run this on a command line on my desktop or on a server? Once you're happy with that, you can say, now I want to integrate with the rest of my workflow. Maybe there is an automated pipeline that fetches some data. I want to integrate my workflow within that. So we'll say, take the model in QGIS, we can export that as a Python thing and we'll integrate this into your workflow. So we'll see various levels of automation and what QGIS provides you with that. So first, I want to talk about processing framework. This is a set of tools and systems within QGIS which allow you to automate your workflows. And when you're thinking about automation, you need to use the framework that QGIS provides. And once you use the framework, you'll be able to take all your steps and combine into a workflow. So what's the processing framework? It's a way inside QGIS which allows you to standardize your workflows where all your GIS tasks would require selecting some input data, configuring some parameters, and generating outputs. Now instead of every tool trying to figure out how to do this, QGIS provides you with a framework saying that if you use this framework, the users will have a standard interface. They'll know how to set the inputs, how to configure. Only thing you need to implement is the custom logic of a tool. And that's what the tool provides. This would be the recommended way to run all your analysis. So from today onwards, if you don't take away anything else from the talk, it is that start using the processing toolbox and processing framework. You will be much happier. Your analysis will run faster. You'll have access to the tools which are generally faster than other alternatives. Even within the QGIS, most of them come with multi-threaded implementation. So you have access to all the CPU cores that your computer provides. And in general, whatever you do can be automated if you choose to. It consists of multiple things. One is the processing toolbox. This is the hub of all your tools in QGIS. Each tool also has a batch processing interface. So you can say, I ran this tool on one file, I want to run this on every file in this directory. And you can just configure it to do this. Every tool in the toolbox also can be run as a model. So you can say, if I use this tool in my workflow, I can plug it in my model, so I can run it as an automated pipeline. It contains some other things about every tool you ran, there's a history recorded. So if you ran a tool, you configured it, and you ran it, and you said, oh, I made a mistake. So you can go back to the history and load the previous invocation and then change some parameters to this. Or if you say, I forgot what I did last week, you go back to history and recall it. There's also a result viewer, and there's also a command line tool, which is provided by the processing framework. So we're going to take this case study. The idea here is don't focus too much on the case study, but let's say we have a problem that requires the steps similar to what is given here. And how can you think about the problem and solve it in QGIS, also with an eye to automation. Okay? And for people who are in the water resource domain, this will be very relevant. Some of the techniques I'm going to show you is maybe you might not be aware that QGIS can do this in a built-in tools for doing this. So let's learn a bit about this problem. Typically, when you want to measure rainfall, rainfall is one of the most important parameters for any hydrological application. Right? You want to know how much did it rain. If you are looking at a basin, you want to know what was the total rainfall. And we can't measure rainfall everywhere. Right? You can only measure rainfall at specific points. So how do I take those point observations and estimate how much did it rain in this city, this region, this hydrological basin? Right? So that's the technique of calculating the rainfall. So how do we do this? Well, there are many techniques developed over time. More slow. This is a statistical technique. Let's say I have some point observations and I'm going to estimate how much it rained in between those observations. I know it rained this much here, but I don't know how much it rained maybe 1 kilometer away. So how do I estimate that? And there are some techniques. So first is average. We'll say there are 5 stations in this city and this was the rainfall. I'll just average them. And that was the average rainfall in the city. Works okay, very simple technique. But again, if the stations are, some stations are grouped at one part of the city, another part of the city, averaging may weigh certain region more. So again, it doesn't work where you have stations which are not very dense and not very homogeneous. The second one, you can apply a slightly different advanced technique, which is called Thiyaku polygon or Voronoi polygon, widely used in the climatology domain, where you say each point's influence is, take any point that you want to observe or want the value, you pick the nearest point to that and take that value. Right? So you basically do an area weighted average over the entire region. You say I'll divide this region into Thiyaku polygons, where each polygon represents the closest area to the nearest station, and then I'll take how much area that polygon covers, and I'm going to do the area weighted average. This also works decent. There's isohydral method. This kind of takes a little bit of interpolation approach, where it generates lines of equal rainfall, and then between 2 lines of equal rainfall, you can do a linear interpolation and find out. There's also inverse distance weighted. This is in interpolation method. You say the observation at rainfall at this point is inversely proportional to the distance of the rainfall that was recorded. And you do this interpolation, you generate a grid value. At each grid, you'll have some value, and you can sum up the grid values or take the average, and you can get the values. There are geostatistical methods like kriging or linear regression, where you say, I'll take into account the spatial autocorrelation, where certain points are grouped together. I'll account for that, and you can do kriging, or you can say rainfall is also highly correlated with elevation and other climate parameters. So we're going to build a regression model and then use that to estimate the rainfall everywhere. Right? The details of all of these methods are given in this particular manual. It's part of the National Hydrology Project for India, put together by World Bank. Really nice manual which highlights how to work with rain gauge station data. And once you have the station data, what are the things you need to be aware of, how to process them, and so on. And the method I'm going to show you comes from, implemented from this manual. So if you want to learn a little bit more, I've linked to this report. You can read the report and learn more about it. I'm going to focus on this method of Thiyaku polygon, not because it's the most accurate, but because I can show you some interesting tools in QGIS. All of this can be done in QGIS. The inverse distance weighted, there's a IDW interpolation tool. If you want isohydral method, you can use thin interpolation and then do contours. And you can generate contour polygons and then average each contour polygon. So that also works. There's a kriging plugin in QGIS. Till recently, one of the top questions I was asked for QGIS was, how can I do kriging? And there was no good answer, but there's a new kriging plugin which makes kriging very easy. So you can install the plugin and do that. So we're going to focus on the Thiyaku polygon method. I'm going to highlight the method and then we're going to go through the implementation. So this is the, say, one basin. Right? We're going to take data for Florida and some stations. No particular attachment to Florida, except that there's a lot of good open data for the US, and I can share the data with you. And if you have the data for your region, you can do the same thing. So here's a one basin, and here are the point observations. This is a rainfall, cumulative rainfall for 1 month. Right? And these are the stations which recorded this much precipitation. Now, if I ask you what was the total average rainfall within this basin, that's a problem that we need to solve. If you want to say what was the runoff, if you want to calculate runoff, you want to know what was the average depth of rainfall that fell on this basin. Right? So you could do a simpler average, but you can see that the stations are much more dense at the north of the basin. The south, there is less rainfall, but there are less stations as well. So we want to actually do an area weighted interpolation, and that's why we're going to use the Thissen polygon. So the first step is we're going to compute the Thissen polygons. So this is what Thissen polygons or Voronoi polygons look like, where each point inside a polygon is closest to the station that we are computing the polygon for. So here if I look at, we'll say 5.35, every point inside the polygon is closest to that station recorded 5.35 than any other station. And you can generate this. Once you generate these polygons, we'll just clip it to the boundary of our station, and this is what we have. Right? So once we have this, we want to now compute what was the area weighted average inside of this. So we want to take the average of this, but we want to give more weight to the polygon with the larger area, less weight to the polygon with the smaller area. Okay. So to do this, we want to compute the proportion of area for each polygon. So the proportion of area for each polygon would be the area of that polygon divided by the sum of area. It's simple. Area, and in QGIS when you're writing an expression, your dollar area refers to the area of that feature, and sum of dollar area will be the sum of area for all the features in the lake. Okay, so if you this formula, dollar area by sum of dollar area, will give you the proportion of the polygon's area. And the contribution of that particular polygon will be the precipitation multiplied by the fraction. Okay. So if you compute the average, we'll say this polygon had X amount of rainfall, and we're going to weight it depending the fraction of the polygon, and this will be the contribution. So PRCP will be the attribute that we'll save it. So double quotes in QGIS refers to the attribute value. So we'll say the current features precipitation recording multiplied by the proportion of the area. And we do this for each polygon, and when we sum it up, we'll have the area weighted average. Okay. So this is what we will implement. So we take our data, and then we apply this formula, we end up with one value, which is the area weighted average. Okay. And we'll have to do this for every basin in this whole state. So we'll take the data for each state, and we'll say there are multiple basins, multiple stations. We want to do this for every basin in the state. Okay. So we'll first solve this using the toolbox, then we'll automate that. So the workflow that we're going to follow is we'll first take this data and do some cleaning up. Every data that you work with in real life, you need to do some cleaning. There's rarely perfect data, right? Null values and bad data and so on. Right? So we'll show some of the tools in QGIS which allow to import data, clean up, we create Thissen polygons, clip it, intersect with the basin boundaries, because the Thissen polygons are their own polygons, right? We want to intersect with each basin boundary so we can get all the polygons within that each basin. And then we're going to aggregate and compute the area. Okay. I have a tutorial on my QGIS tutorial site with a step-by-step instruction. So if you feel what I'm doing is too fast, you missed that setting, don't worry. The idea for this is just to show you that how you can think about this problem. Now, if I give you this problem, and if you're a QGIS user, you can probably solve this. It's not going to be difficult. Some of you may take an hour to solve it. Some of you will do some manual work and solve it. Some of you will take a few days to struggle with it and solve it, but it's solvable. I'm going to tell you what is the right way to solve this. If your goal is to process it fast, if you want to process a lot of data the most efficiently, and then if your goal is to automate. Right? So that's the kind of thinking process that I want to show you on how to solve such problems. Okay. So I'm going to dive into QGIS. So our source data comes as an Excel file. Hydrologists love their Excel files. I realized it when I worked on the project. You will get a lot of Excel files, and they want their output in Excel files, which is great. Actually, I'm a fan of Excel files when it comes to working with tabular data compared to CSV files. Even for open source, the XLSX format is an open source format. It preserves the column types. CSV doesn't do that. You need a sidecar file and so on. So if you want to have a tabular data, I actually prefer Excel files. So I have an Excel file like this. It's got a station name, station ID, lat long, and precipitation. Okay, for 1 month. This is 2020 July. and I want to get it in QGIS. One of the things that some of you might be surprised to know is QGIS can work with Excel files natively. You don't need to convert it, you don't need to do anything. You can just drag and drop those files into QGIS. So here I have my Excel file. I'm just going to drop it to QGIS. Okay? QGIS can import Excel files, also export Excel files. And if I look at the attribute table, it came as a table. There's not a spatial data yet. Right? We have an attribute table in QGIS. Drag and drop Excel files. This is a spatial data because it's got lat long column. So let's convert it into a spatial layer. We're going to use the processing toolbox. So if you go under processing, this is all your processing framework tools. Right, so we're going to open the toolbox and you can search for a tool that can do this. If you're not been paying attention, the processing toolbox has grown to have literally hundreds of tools. If you're a user of QGIS for a long time, you might be used to doing things in a certain way, you might be used to certain plugins, but there are now native tools that can do this. And even though I'm working with QGIS day in and day out, sometimes I discover tools that existed which I didn't know about. Right? So do search, when you have a problem, do search for the toolbox and you might find a tool here. So for this, we're going to use this tool for create points layer from table. Right? So if you have a CSV table like this, you want to create a spatial data, you can do this. This is particularly important for automation because what if you have a CSV file? You can bring it into QGIS, configure which columns are lat, long, etc. But it's still a manual step. When you're building a workflow, you say, I have my file somewhere, I just want to bring it. I have an Excel file, I want to bring it in as a point here. So you can use this tool and do this. So let's use this. Every processing tool will look similar. You will have some inputs that you can configure. There will be documentation on the right which shows the information about the tool, and then when you run it, you'll get an output. So here we're going to say this is the input layer, X field longitude, Y field latitude, X and Y coordinates are not lat and long, it's longitude and latitude. And this is a common kind of confusion that happens with geospatial data. So if your data that you import ends up looking long, it might be that you might have switched the X and Y coordinates. So we specify longitude column as the X field, latitude column Y field, and we just set run. By default, the processing tools will generate a temporary layer. And that's good, right? Because when you're doing GIS work, you'll generate so many temporary files, intermediate files, which you don't want to manage. Here, you generate a temporary file, and when you close QGIS, it will just go away. Right? You can choose to save a file. If you want to say, I want to see the result and save it on my disk, you can choose it. But generally, you will only save the result, not the intermediate inputs. Right? So let's run this. And now we have a point layer that was created from an Excel file. Okay? And we have the lat long along with that. So here is our point layer and attribute table. You will see that this one contains some null values. There are some stations have null values, no rainfall recorded. So we want to remove the null values first. Right? Null values are different than zeros. So there are some records with zero. Zero means I know there was zero rainfall. Null means I don't know what was the rainfall. Right? So null and zeros are different. So we want to remove the null values. And to remove the null values, you can just search for null in the toolbox. You'll get some tools that deal with null data. One of the tools that we can use is this tool for extract by attribute. This allows you to select some features from a layer based on some attribute query and then extract them and create a new layer. Typically, QGIS users will do it in 2 steps. Right? You will go and select the features and then you right click, extract selected features. This is just one step. Okay? So there are some extraction tools. You can say extract by expression. If your query is a little more advanced, you can use an expression tool to do this. Extract by location. If you want to say I want all the stations intersecting this basin, extract by location. So extract by tool, we're going to take our point layer and we'll say PRCP, precipitation, is not null. Okay, we want to extract all features where the precipitation is not null. And now if I look at my attribute table, for QGIS user there is a shortcut F6 to open the attribute table. Typically when you will create a new layer, you want to see the attribute table, so F6 is your shortcut to open the attribute table. And you can see now I have no null values. Right? I have some zero values, but I have no null values in my data. So that's the first step to me. Alright, now it's time to create our Thissen polygons. You can search for Thissen polygons. You can see there's a tool called Voronoi polygons. That got hit because all the QGIS tools are indexed by the description, by all the metadata that the tool has. So you can just search for what you want to do and you'll find the tool. You don't have to remember the name of the tool. When you create a Thissen polygon for the region, you typically have some polygons may end shorter than your boundary, so you have some buffer region. You say whatever region I have, extend your polygons a little bit outside. So when you clip it, you have some data. And so we'll have a 15% buffer region. We'll run this. Change the color slightly. Right, so this is our Thissen polygons. And if I just change the order, you'll see that each point has a polygon surrounding it, which is all the area closest to that point. Thissen polygons go all out towards this. Let's just clip it to the state boundary. So I'm going to bring in the state boundary. Here you have the QGIS browser. You can browse the data on your computer as well as networked directly from within QGIS. I'm going to open this and I have my data here. So this is a Florida.shapefile. Let's bring in the shapefile. Yeah, so this is a shapefile containing the state boundary. Let's just clip it. We'll search for the clip tool and we'll take our Voronoi polygons and clip it to Florida. Clipped. So we have Thissen polygons for the states and we have the entire region covered. Now let's bring in some hydrological basins. Right? So this is the data that comes from hydrosheds. These are all the basins. They have different levels. I've downloaded data for one level. This is the level 6 basins for the state of Florida. And each basin covers some region. So now I want to take this and take it. I want to know the Thissen polygons within each basin. Right? So I want to intersect my Thissen polygons with the basin so that they'll get cut at the basin boundary, and I'll also know which was the basin that this Thissen polygon belonged to. Right? So let's try doing this. I'm going to take this clip layer and I want to intersect it with the high base layer. So we'll do the intersection, take the clip layer and the high base. I get an error saying your hydrological basins some features have invalid geometry. This is also one of the advantages of the processing tools. The processing tools have a configuration setting where you can say how to deal with invalid geometries. There are certain geometries which have self-intersections. They have dangles and so on. And if you do your regular tools, you don't know how they'll be handled. In the processing tools, you can be explicit. Here the default setting is stop wherever you have an invalid geometry. And you can check where is the invalid geometry. Once you figure out, okay, I need to fix this, there's a tool that you can use to fix geometries. Right? So there's a fix geometries tool. There's also check geometries, which will tell you where the errors are. You want to make sure the fixing will do this correctly. Typical fix involves mostly the errors are self-intersecting polygons. So if you have an hourglass looking polygon and it's self-intersecting, those are invalid. So this tool will basically turn that hourglass shaped thing into two polygons as part of the same feature. So it will be a multi-polygon. So the output of the fixed geometries is always a multi-part geometry. Okay? So just to make sure, sometimes some tools will say I will accept only single part geometries. So if you do the fixed geometries, you'll end up with another error. So then you will run one more tool, which says multi-part to single part, and then you'll be able to do this. In a lot of my workflows, I have this as a first step, because when you're getting data from some providers, typically they have some invalid geometries. I don't want to fix them manually every time. So in my workflow, the first step would be fix geometries, proceed. Okay. So I just fix this. Now we're going to go back. We're going to go to our history. See, these are all the tools I ran today. So I want to go back to this intersection tool. You can double click. I'll have the exact configuration I did. I'm just going to change this input instead of this. Use the fixed geometries. I'm going to do the and I can run this intersection tool. So you can see now I have Thiessen polygons clipped for each polygon of the basin. Let me show you the attribute table. Since we did this intersection, we have this Thiessen polygon, we have the precipitation for that polygon, but we have now the ID of the basin as well. That this polygon is cut through the basin boundary and we know which basin it belongs to. Okay? And we have the precipitation for each polygon. And now it's a time to say, now I want to calculate the area weighted average precipitation for each Thiessen polygon within each basin. Right? So this is our key identifier, high base ID, which is the basin ID for each polygon, and we have the precipitation. So we want to do this. So what we want to do is we want to take all the Thiessen polygons within each basin, take the average, and do this for each polygon. And that operation is generally known as dissolve. So you can run the dissolve tools and dissolve by high base ID. And it will dissolve all of those polygons that have the same ID. But the dissolve will just give you the dissolve geometry. Typically what you want to run in this case is dissolve with statistics. Right? So you dissolve, but while dissolving, once you find all the features, dissolve the geometries, but also do some statistics. And that tool was missing in QGIS for a while. In recent versions of QGIS, there is a tool, a really powerful tool called aggregate. I just searched for dissolve, right? I searched for dissolve, two tools, dissolve and aggregate. So aggregate is your dissolve with statistics in QGIS. Okay, so I'm going to show this. I'm going to take the intersection. Sorry, the text is not clear, but the first one is a group by. So what's a group by field? And that's a high base ID, right? So for a group by each polygon by the high base IDs, I'm going to select that. And then for each field, what do you want to do? You'll find 10 polygons for each base ID. What statistic do you want for each attribute? I only want the precipitation, right, in my output. I don't care about anything else. So I'm just going to select and delete all of those other columns. I'm going to select this and hold shift key, delete this. And this is just configuring, I'm not deleting it, I'm just configuring the tool to say I want only two field, the high base ID of the basin and the precipitation. I'm going to change the order. And what do you do with the high base ID? You'll group by high base ID for each basin. You find multiple values of the thing, what do you want? All the values will be the same, right? So we just say, just pick the first value. So this is how to aggregate. Once you find different values, you can concatenate. If you have different values, you can separate by comma and join that. Precipitation. What do you want to do with the precipitation? So here we're going to apply an expression because we don't want to take the value and just average it. We want to apply the area weighted. Okay. So I'm going to apply an expression. Now we have the precipitation. We're going to say compute the contribution of this. Okay. So multiply it by the area divided by the sum of the area. And we're going to aggregate it as a sum. So each polygon will have this fraction. We'll sum up all the fractions to get the area weighted. And now I can choose it to save it to a file because that's my final result that I want. So I can just save it to a file. Maybe you can go show a geo package file, shape file, whatever you want. We're going to save it as a geo package and run this. So now I have a result which is high base ID and the area weighted precipitation for that. Right, so we got our answer, and few things to note. We got our answer exclusively using the processing tools, and a lot of the tools ran very fast. Right? There's also, if you use the tools, you'll be faster. So I want to pause here and see if there are questions. Maybe in the live stream also, if there are questions, I can take that.
Just for like one particular name, right? One month.
Yeah.
Would we have a time series of presentations?
So the question is, this is for one date. What if we have a time series? So we're going to build a workflow. So once you have a workflow, there are like 6 steps involved, right? 6, 7 steps. Now I said, now do it for the next month. You'll say, okay, give me 20 minutes. I'm going to run this again. What if you want to run this for every month or every day? For example, if your job involves come every day in the morning, give me the area weighted precipitation for this basin, about the rainfall yesterday. Right? So you have to do this every day. You see? So to do this, one option is we build a model and then we can run this as a batch process. So every tool in the toolbox, you can right click and say execute as a batch. That means you can run it against multiple inputs. Right? We're going to build a model next, and once you build a model, you can run the model as a batch process. So that's your answer to how to do it for multiple dates.
Because over here you had one step where we remove the null values, right? So when we have a time series, certain stations might have null values on certain periods, but then they again have.
Yeah, so the question is how to deal with null values in the temporal data. So you could choose to remove it, or in the manual, if you look at the manual, there are techniques on dealing with station data, how to validate. Because station data can have a lot of problems. What if it shows null or 0 because somebody forgot to record it, not just because it was 0. There are cases where station has tree growth over it, and suddenly it's not recording all the rainfall. Right? So there is a way to validate and make sure that your temporal data is correct, and maybe fill it with some interpolated value. In the last slide of the presentation, I have a post that about spatial homogeneity testing for rain gauge data. And this is another very advanced QGIS thing, which is part of the same manual, where you have this rain gauge data and you want to validate. And this involves things like, I'm going to check the value of all the stations within a 20-kilometer zone and compare the value and the statistical deviation from that value. And it has to be within certain limit. And again, you say, I don't want all the stations in a 20-kilometer neighborhood. I want to pick a station within each quadrant. So you can imagine a quadrant and say 0 to 90 degree region, pick 2 stations. Another, pick 2 stations. And how to do all of that in QGIS, I have all the expressions and the thing linked in this. So you do some first validation, and you found a suspect station that this is likely wrong. You replace it with the interpolated value from the neighboring stations. All right, moving on. So how to automate this? First step is modeler. This is a graphical modeler, very approachable for people who are just used to desktop tools. So this is your first step in automation. You don't need to have programming skills. You just say, I know how to solve this in QGIS. We just did. Just plug all of those tools together and build a model. You can save the model on a computer. You can save it in a QGIS project. This is also a pro tip. If you're working on a project and you build some workflow, there's a button, save this model inside the project, the QGZ file. So you save it. That means your model is always safe inside the project file. So you share your project file with somebody, they'll have the model right with them. Maybe you build a machine in your office, model in your office machine, go home, or you go to a different machine. Where's your model? You don't have to hunt around for this. It always is part of your project. So generally, when I recommend that when you share your data or you send it to somebody or backup, put your model inside your project. So that means whenever you find that project file, you not only have the source data, but the way to use the source data and generate the output along with it. It's always there. Right? So that's a useful thing to have. You can define the parameters and build a model. So if you're new to modeler, I have a really big and nice tutorial, step by step, how to use the modeler. So some of the stuff I'm showing is like, why did I choose this option? How do I do this? Look at this tutorial. You can find how to take any workflow and convert it to a model. Right, let's first do the model. How are we doing on time? How much time we have?
55, we have half an hour.
Half an hour? Okay, great. So I'm going to actually build the model, otherwise I will show you the result. So
Speaker a little
closer. Okay, thank you. Alright, so I'm going to So I've loaded these 3 layers. This is Excel file, the state boundary, and my the basin boundaries, right? And I'm going to take this and build a model. So let's start this. To build the model, you can go to Processing, Graphical Modeler. This gives you this new window where you have a canvas where you're going to drag and drop different blocks and define your workflow. On the left, you have your toolbox. So everything that is in the toolbox, your scripts, models, plugins, everything is accessible in the modeler. So you can use all of that. There's also one tab called input. So you take some input and then process that. So the first input we're going to use is our Excel file. Right? So we're going to use the vector layer. Vector table is just vector data. Right? So we're going to just say stations. So this is a station data. We'll say geometry type is geometry not required. So we just have a non-spatial input to our model. We're going to bring in our first tool. Remember the first tool? Point layers from table. We bring it in and you have to configure it. So this tool will say, looks very similar to your tool, but it's got a few differences. It says, what do you want to use as input? And here it says, use the model input called stations. Right? So it's a configurable. When you run this, you will have a tool which says, select your input. And you can say, I have a folder full of Excel files, and you're going to go and pick which Excel file you want. Okay? So it's not a static thing. We're just saying this is an input to the model. Whatever the user has chosen, use that. Okay? X field, we're just going to type it, longitude and latitude. Okay. So that's the first step in a model. You can see the workflow connected. The next step, we're going to do our extract by attribute. And we're going to say where do you want to extract the values from, not the input. So you can select here that my input has to be the algorithm output. It's the output of the previous step. Okay, so we're going to choose that and we're going to see some options. Say, oh, there's a point from table that was created. We'll use that and we'll do a query. Selection attribute is ERCP and operator is null. Okay. This is our second step. We have our non-null values. We're going to create our Voronoi polygons. We'll use the output and buffer agent 50. You can see here it says enter name if it's the final result. Otherwise, it's going to create a temporary error. At any point, you can just enter a name, just saying enter name and run the model to see what it generates. If you have a lot of steps and say my output is empty, where did I make a mistake? So any intermediate step, just enter a name and it will be generated. You can generate multiple outputs from each model. Right? So this is a quick debugging tip. Alright, so we have this thing, your Voronoi polygons. We want to now clip it to the boundary layer. So I'm going to define one more input here. I'm going to bring in one more vector layer. You can bring in anything, right? Anything you see in QGIS. You can bring in a number, enter a text, enter a drop down, whatever you want to do. But we're going to bring in a vector layer and this will be our state boundary. And we'll say this has to be of type polygon. So user can only choose a polygon layer when they're specifying that. So we'll now do the clip. We'll say take the Voronoi polygons and use the input state boundary to generate a clip layer. And you can see that this clip layer is now connected to two things, the input and the previous output. Pay attention to the connections because it's very easy to make a mistake. You might select the wrong layer and this will be connected to the previous step. So you can just use that as a visual guide for selecting this. Next, I want to bring in my hydrological basins and overlay and do the intersection. So we'll do one more input. We'll say basins. We'll name it polygon type. But this has this geometry problems. So I'm going to first fix the geometries. We'll say fix the geometry of the basin. Okay. So this is very helpful if you think about now you have some data which always needs fixing. Just add that as a first step. And always wherever you select, it just get cleaned before coming in. In the real world data that I work with, I had one more step because the data that comes from IMD in our case had station names which were spelled differently than what the local spellings were. So for example, Ramnagar and Ramnagara, same station name, but we want to use Ramnagara, not Ramnagar. So we had one more step, field calculator, create a new field, the station name, and condition, case, if station is Ramnagar, replace Ramnagara. Right? So because a few handful of the cases, you can just code those rules in your data. And it's sometimes just easier to just code these rules in your model rather than trying to come up with an algorithm. So there are 4 or 5 stations which always have this problem. So you do this and you run as a first step. That means you can directly work with the Excel file sent by your provider. You don't have to go and fix this manually. Right? So you can have those rules as part of your model, cleans up the data, fixes these things, and then passes on to the next model. Okay, we have these 2 things. Let's do the intersection. Take the clipped one and use the fixed geometries. We have our intersection, and finally we'll do our aggregate. And here we will use the intersection. Here you can see there are no fields available here. Why? Because this layer is not generated yet, right? It's still part of the workflow. We don't know what are the fields from the previous layer because we not run the model. So in the modeler, you need to know this before. That's why it helps to run that manually once, right? We just did a workflow, so we know what those fields are. We can just enter them here. Right? So I'm going to just say this will be the high base ID. And then the field we want, we can just enter here. We'll say the be the first value, and type will be 64, and this will be our expression, the expression that we entered previously, this one, and this will be the sum. And we'll call this done. Okay, so we'll run this model and do this. Let me run it. I hope I've configured everything correctly. If not, we'll see what happens. So here when you run this, you can see there's a tool that comes up, very similar to our processing tool. Some inputs, some configuration parameters, some output. And this is the tool that we built just using the drag and drop. It's got all the different workflows. So we'll select the basins, select the state boundaries, and select the stations, and we run this. You can see step 1, step 2, step 3, step 4, step 5, step 6. Just one click, everything runs. Let's see in QGIS, we have our result. Worked. Right? Thank the demo gods. So we have generated this by one click. We loaded the data, ran a model, generated the output. Now imagine you have to do this every day. You just solved a major pain point for yourself. This model is also very easily maintainable because it's just in your graphical model. You can just say, oh, there's one more step to be needed. Maybe now they started misspelling another station as well. So go to the model, just change that condition, right? And you can inspect the model anytime. And this is something you can put in your project. So you can now put this button here. When you save it, it's going to save it locally as a model 3 file, but you can say save model in project. It will be part of your project. Send it to somebody saying, oh, you have to run this every day? Here, use a model, you can run it every day. Once we have the model, you can see I have the saved model. Once you have the saved model, you will see under project models. So when you open a project like this, so if you download the data from this link that I gave you, and open this project aerial beam rainfall, you'll have this project models folder. Even if you download, you have the project models, and my model is right there. Right, so the model which I built is already here. You can edit it, you can use this, and you'll be able to work with it. Right, so this is for reproducible workflows. Anybody can reproduce the data. I don't even need to save the output, right? Because I have the inputs and I have a way to generate the output. That's all I need to save. I can do this. I can also right click and say, run this as a batch process. Run this against this 100 Excel files that I have, or 365 Excel files for each day. I get 365 outputs. I worked with somebody who asked that my job every day is to come in at 9 o'clock, download latest data, weather data from FTP server, do some cleaning, do some analysis, create a map, and send it to my colleagues. And once they learn this workflow, automation, they build the tool, they now run it at 6 a.m. every day in their office computer. And when they come in, the map is ready, and you can just send it. Right? You can enjoy 1 more hour of breakfast or time at home. Right? So, questions? Right, now you say you did this, and now somebody says, this is great. Now let's just run it on a server, because our data sits on a server, or an FTP server. Some data comes, and I want to run this on a server. So you say, okay, how do I log into the server, open my model, run this? And you say, I want to do this automatically. 6 o'clock, I want to run this every day on a server, or maybe I have a condition. The new data was produced by NOAA, and now I can have a job that downloads the data, and I have the data. Run this model. Okay. So the easiest way to do this is you use the command line tool that comes with QGIS. Okay. This was a very common task that people wanted. I want to run this processing tools on the command line without starting QGIS, without me being present. Just run this. Right. So you can install QGIS on the server. I have some tip I've linked in the next slide. How to install it. If you have a server, AWS or somewhere, you can use Conda. QGIS has now Conda packages. So you can say Conda install QGIS, and you're going to get a full working version of QGIS along with the UI. But you'll also have all the packages. You'll have the QGIS process too. So imagine you just SSH to a server, use Conda install QGIS, and now you have a QGIS process too. You can just run it.
Interesting.
Yes.
So QGIS and command line, we don't have a proper documentation for this command.
Yes, you don't have a proper documentation for command line. That's my job. I have a blog post written last month documenting the whole tool.
These days I'm using this command line tools, but I found it difficult to use it.
Yes. So I spent a lot of effort in, I have a detailed blog post on how to run this tool, what are the parameters. Again, not only on Windows, but Linux and Mac as well. Everything, there's a slightly different syntax. So I have a link here in this slide. You can go and do this, and this is something that will help you. So you can install QGIS, whatever you have, and then you can run this process too. This is the guide I was talking about. Step-by-step instruction, where to find the tool, how to run it, how to configure it. It's available here. Do let me know if something doesn't work. I tested, typically everything I do, I test on Windows, Mac, and Linux, and to make sure it works. But again, if your configuration is slightly different, then it might be slightly different. So let's see how to do this. So let's say I have this model, and this data is coming from a geo package. Right? There's a geo package on my system, and I've loaded this data. It could come from a directory, it could come from a database, doesn't matter. But the first step in running this command, and you just load the data from wherever you want to run it from. So I've loaded this data, and I'll say my Bayesian boundaries are this, rain gauge data is this, state boundary is this. Okay? Once you configure your tool, this is a model. It can work with every tool as well. So any tool that you say, I want to just clip this data, or I want to generate some tiles using this. So whatever you want to do, configure it here. At the bottom of the tool, there's an advanced tab, advanced section. And it says here, copy as a QGIS process command. So whatever you configured, you will copy it, you will get command line to do this. You will then copy this, open Notepad, paste it. So this is your full command that says how to run this model on the command line with the inputs configured. It says QGIS process run project : aerial mean rainfall. That means from this project, I have a model for aerial mean rainfall. Run that model, and these are the different parameters. Bayesian boundaries is coming from C, users usual downloads, automating geoflows, output geo package, layer name, hydroshift basin. So this is a path, right? It could be from anywhere, and you can do this. One slight problem with this is this, since they have to do this for Windows, Mac, Linux, this is not customized to the operating system. So you'll see if you try to run it on Windows, it'll say single quotes are not recognized by command prompt. So you need to just replace single quotes with double quotes. Okay, and do this. So I have the command here in the slide deck, the same one. And also I'm using not the project model, the model that I've saved locally in QGIS. So that's the few changes. So open the command prompt. Okay, so I'm going to open the command prompt and I'm going to run this. No special configuration, nothing. You just have to run this. Where to find this? Well, if you look at my post, I'll show you where to find the tool compared in your operating system. In Windows, the tool is available here. So if you type QGIS_process, I can't find it because it's not there. It's in this folder where you install QGIS. It's in C, OSGFW, bin, QGIS process, QGIS LTR.bat.
Add it to the ELB, right?
Huh?
Environmental variables.
Yeah, so why this is not an exe file? Because it's a batch file which sets all the environment variables to where to find all the QGIS libraries and then calls QGIS process.exe. So that's a batch file we got. On Linux and Mac, you have to set those yourself. That can be a painful thing, but I have documented those on my blog post. So on Linux, this is where you set your paths. This is where you set your this thing. If you're on Linux, use Conda. If you want to install Conda, all the environment variables set. You just say Conda activate this environment and just run QGIS process. It just finds it. Right? On Mac, I have some instructions to do this, and you can use that as well. So you can see I've ran this. It finds a command that says this is a syntax, and you can just run this. So I'm going to take this thing that we copied from our tool, and I'm going to. So this says find this QGIS process, run model, aerial mean rainfall with this inputs. And I'm going to save this output as test.shp in my downloads. Yeah. Just want to show you that there is no test.shp yet on my downloads. Okay. You can even close QGIS, you don't need QGIS running. We're going to run this. And it says model processed. 3.3 seconds, done. I have test.shp created in my downloads. Let's look at it in QGIS. Test.shp with my area weighted info. Okay. So this is your next level of automation. You don't have to be present, you don't have to click buttons. Copy this command, run it. You can now schedule it on your Windows scheduler. So you run this command. You can have a cron tab on your Linux or Mac and run this automatically. Questions? Any live chat questions?
No questions, sir. I had one question. The path there is not like compatible with your Windows path. It was forward slashes.
Yeah.
How did it?
I think it just works. This one you can see. This one internally it just converts it. So it's a forward slash instead of backward slash, but it works. So even I saw this as let me run it. It worked. But otherwise you will find and replace with the backward slash. It's a good feature request. Maybe this command has to be system specific. So these are the things like, if you find that, why it's not like that. QGIS open source, right? It's built by users. And I will say, this is something that annoys me, or I don't want to do this. Go and open up the code and say, how can I make this system specific? And you can start contributing. There are a lot of guides in the QGIS.org website, how to start developing it. And the community is super supportive. If you say, I want to help, I want to contribute, people will help you do this. And this is maybe a chance to become a QGIS developer. Right? So again, something that you see that annoys you, you don't have to rely on some big corporate to go and do this. You can do this yourself. And that's the beauty of open source. All right, the last step. You showed this to your boss, it's like super cool. But we have this on running is just integrate with the rest of our app. Maybe in our app, somebody selects the basin and clicks run. I want that to give me the aerial info. You did this? Yeah?
I was about to ask, can we integrate
can we integrate with the app? That's what everybody wants to do. We have an app, a web app, and it's written in Flask and Python or Streamlit, whatever you do, and like I want you to run this on this. Now, how do you take this and do this? So one option is I'm going to figure out how to do this in Python. I'm going to figure out how to do this in GeoPandas and write this thing. A lot of this stuff is very hard. While GeoPandas is great, I love GeoPandas and other libraries. Some of the stuff tools that QGIS provides are very implemented and quite complex. So GeoPandas doesn't have those implementations. You have to implement it yourself, and maybe you won't be the most efficient coder and you won't be the most efficient implementation. So simple things like this, I want to generate points along lines, right? That in GeoPandas you have to write your own function and do this. QGIS is a built-in tool. Why don't I use QGIS's tool to do this? QGIS tool is also multi-threaded. Somebody once told me that they use the QGIS's raster to tiles algorithm. You have a map or you have an image, you create this web tiles for the web map. All the tools, GDAL to tiles, other tools, they're all single-threaded. QGIS has a multi-threaded implementation. So you can now have a server, 16-core server, and you can run this. You're going to get all multi-threaded implementation, and you can get the speed up. You don't have to implement it, you can just use QGIS. How to do this? Well, install QGIS on that server. Conda install QGIS. You have all the QGIS libraries. You now need to take this and run this Python, and say when somebody clicks on this button, call this Python file and run this. So let's see how to do this. So any model or any that you create can be exported as a Python algorithm, and it can integrate with everything. So you get a Python script, which is a PyQGIS script. So Python script using QGIS API. So the whole framework, processing framework, is exposed as with an API. So whatever you are doing can be done using the Python APIs. So when you do this, you get a Python file that says load this input, do this, call this tool, and do this. You have a full-fledged working Python script. Now to run the script, you need to tell your Python how to find QGIS libraries, how to find the inputs, how to find the model, and so on. Right? So that requires some additional files that you need to do. You need to set the environment variables. You need to initialize QGIS in a headless mode. So from Python, you can say QGIS.start. But and there's a parameter that says false. False means don't start the UI. Just start QGIS, load all the libraries, and then run the model. Okay. To run a processing tool, you need something called a provider. So in QGIS, the default provider is a QGIS, the native provider. So when you see the QGIS prefix, it will be project : native : right? So you need to have a provider which runs this. When you're running a custom model like this in Python, you need to create a provider. You can name it anything and say, and it's just a template. You say, I want to create a provider which has one algorithm. If you have multiple algorithms, you create a provider which runs multiple algorithms. You create the provider, and then you run the algorithm. Again, step-by-step instructions for doing this is I teach a course on PyQGIS. All the instructions how to create those files on the set of environment are here, and you can look up and implement it. But let me show you how to do this. So we are in QGIS. I have a model. Right-click. Last option. Export model as a Python algorithm. Okay, so I'm going to click this. And I have a Python script. Okay, this is a Python script that runs your model. Okay, so I'm going to copy paste, save this as a file, Arial mean rainfall algorithm.py. This is my algorithm. And I'm going to come to the desktop. I'm going to just show this. So this is the file that came out of this. So I've saved it as a .py file on my computer. The second step I need is I need to create a provider. So simple template. What it's saying is there's one provider. I will create QGIS processing provider. I have my algorithm here. Arial mean rainfall. Import that, and we'll say I want to name this provider Arial mean rainfall, and this has only one algorithm. Parent algorithm Arial mean rainfall. If you have multiple files, maybe you say my web app requires 10 models. You add all of this 10 here. Yes, that's a provider that we created. And if you're running on a Linux environment, you're all set. You can just run a Python script that finds your input files and calls this algorithm directly. So processing.run and run. If you are on a system that doesn't have all the configuration set, Mac Windows, you need one more file. Here is a batch script. Sorry, so this is the Python file that you need regardless. So even if it is, you need a file like this. You say import the provider, import processing. This is the QGIS initialization. So you can say QGIS application false. So create a QGIS application, but don't create a UI. And QGIS.init QGIS. So this starts QGIS. You import processing, initialize processing, and you say these are my parameters. Processing.run ADL main info. And once you're done, you say QGIS exit QGIS. So this Python script will start on your command line and will load the provider, will start QGIS in headless mode, run your algorithm, and stop. Which will log. Okay. So this is the script you will call from an app. So once you have an app, you say user has selected this parameter. I'm going to pass it on. So whatever framework you're using, it is going to take those parameters, pass it on to this script. The script will start. For the script to run correctly, you need all this. You need to find all this library, right? You need to find QGIS.code. So if it doesn't find it, you need to set the environment variables. So on Linux, you can set the environment variables, same in Windows as well, or you can just create a file, a batch file. Sorry, I need to show you the file. This is a batch file which just sets the environment. At the end, it will just say Python 3 run algorithm. Okay. This file is different for Linux and Mac as well. I have examples on the linked documentation. You can use whichever you want. Okay. This is the challenging part. I spent many hours and still do. Every new release of QGIS, something changes. So we still keep it maintained so that you can find all these correct versions. Okay. So let's run this. I'm going to try this. I chose to bring my Windows laptop because on Mac Linux it's very easy. People always say, oh, but what about Windows? And that's a QGIS user is Windows. I'm going to show you that it's also possible and works on Windows as well. And if you figure this out, Linux is a piece of cake because all this stuff is just built for Linux. Yes, I'm going to go to desktop. And you can see I have this run script. This script will load the environment, call this run script.py, which will find all my inputs and call this algorithm. And where am I saving this? So I'm saving the output as aerialmean.shp in my download folder. Okay? So I have test.shp from the previous one. Aerialmean.shp is output of this Python. Okay, run script. It's starting QGIS now in a headless mode. I'm going to run this. You get some warnings there. This is basically the QGIS is internally initializing. There is some warnings, etc. Doesn't matter. What we are looking for is output layer created. Done. Right, so algorithm ran, created the output layer, and we will go to QGIS. And I have aerialmean.shp. Same output. Okay. Now this was generated completely using Python without doing that. It can also be integrated into another app. Questions? Yeah.
I think this is a really great opportunity. When you, I just have a question on the output. When you run in QGIS, some can see the GDR command, like what it has done there. When you do it with that, is there also a file that you can see, okay, I will pull back, this is what was done. Like what the processing algorithm has done, like GDRs and this thing, GIF or something.
Yeah, so the question is when you run the tool, you'll see all the command that it ran, right? The full output in the thing. So here, when I run the model, let me just show. scroll around, you can see there's some output that generates here, like what was run. So this is the log output. And if you want to save the log, there is a tool here. So if you open the modeler, QGIS modeler, there's a section called modeler tools. So there are tools which you can use in your model, which makes sense only in this environment. So they're not in the main toolbox. So there is one tool here, save log to file. So this will say whatever log was generated, you save it to a file. So maybe that's something that you can do. Put that and say once it finishes, save the log to a file which you want to see later on. So sometimes when you get an error, you want to see what happened, right? So you can see the log. Right, so I will show this one more time, so if people on the live stream, etc., can see this is what we did. All this data, the Python code is available here. The link, bit.ly link is all you need, and you can access this presentation. So we saw different ways of automation in QGIS. First we saw use the processing toolbox, use the tools, we solved the problem. Then we took it, built a model, we ran this as a workflow. Then we took the workflow, ran it as a command line. And then we took the algorithm for the workflow, saved it as a Python file, created a provider, and launched that from Python. Right? So different levels of automation. And I hope you get inspired to first use QGIS and say that QGIS has a lot of options for you to do automation, even without you trying to start in write code. Right? To start from your workflow that you're familiar with and slowly automate the stuff that you do. So thank you all for your attention, and do reach out to me if there are questions. I would love to. If you use some of the stuff you learned today, I would love to know. So drop me a note. I would love to hear from you. Thank you, and thanks for inviting me.
So thank you, sir, for presenting this. I am sure many of you would have got benefited from this presentation.
Any questions, yes?
Any questions to Ujaval needs to be answered, please here.
Maybe I will take it after.
Okay, during the network section, if you want, you can ask personally also. Okay, so now we will have a self-introduction section where you introduce yourself to other fellow mates. Where just say from where you are, what's your background, where you are working, and after that we'll have this for 15 minutes, and after that we'll have Mr. Raj's presentation for another hour, and then we will have a small Q&A session for 5 minutes with both the experts, and then we'll have tea and biscuits before we are dispersing as a networking. So this is the agenda for the rest of the day, and we will start from the back. So whoever, yeah, we can start. Just your name, your background, and where you're from.
Hi everyone, this is Satyukt, and I'm working in a graduate engineering practice, more related to water resources.
I guess I'm working as CS.
Hi everyone, I'm Bhagat working as senior project administrator at Ujaval. Mainly in GIS for water resources and power development. I'm a QGIS
I'm working at radio, formerly known as R1 system. I'm GIS images. We work on drone stuff like creating large scale mapping and some project which is a government project we are working on. This is we work mostly on SAR data and optical data for the agriculture purposes. That takes preference.
Hello everyone, my Precious. I'm pursuing my MTech in QGIS as well. Hi everyone, I'm Vivek. I work as a DevOps and Cloud Infrastructure Engineer in the FinTech domain.
Hi everyone, I'm Apupa. I'm from Bangalore and currently pursuing my MTech in Emergency from CIT, and I'm currently interning at Regional Emergency. Hi everyone, I'm Ramya. I'm an ecologist. I work with Wildlife Conservation Trust, it's an NGO. We do quite a bit of hydrology related work, so which is why it's like good 6 years.
Very good morning everyone. I'm Ujaval Gandhi. I'm pursuing MTech in Geospatial at QGIS. I take a moment extra for the organizers for bringing Ujaval Gandhi sir here because he's like Dona Shalya for many of the ecologers around here for inviting me and showing the thoughts of GIS and I am Bhagat. I work at Box Data Institute for the search.
Hi Satyukt, I work as a processing engineer at Analytics. My work basically entails automating workflows just like Santhosh, and it was a very good lecture. I hope I can implement something from what I learned. Thank you.
Hello everyone, I'm Palanichamy. I'm a water resource engineer. I studied MTech in remote sensing, but I have been working in water resources and mainly working on flood related space. My day is not complete without QGIS. So I've been using it for the past so many years, and really nice to see so many people interested in spatial and it's good to get to know what it's about.
Hi, my name is Stanley. I'm working as a hydraulic modeler in Atkins.
Hello everyone, I'm Soumya. I'm currently in the final year of my, hopefully the final year of PhD at Indian Institute of Science, and I work in water resources and environmental engineering. I was working on ArcGIS, but since past 6 months, QGIS has literally changed my life. Looking forward to networking with all of you. Thank you.
Hi everyone, my name is Bhagat. I'm a senior PhD scholar at Indian Institute of Science as well as a consultant with WRI. This is one of the first Let's Meet Spatial talks that I'm actually attending. I know a couple of the people who have been very much involved in getting this together, and thanks to all three of you. I would see Thiyaku together. Big thanks to you all.
Hi everyone, I'm Vinam. I have been working on WRI. I'm staying in Bhopal. I studied my MTech in remote sensing and GIS from IIRS with specialization in urban domain. I have been using GIS and remote sensing in urban disaster management and various dashboard development processes. And in the past week, I have forego many things that I used to do in Python, and I might just migrate to QGIS instead because of this.
Hi, my name is Bhagat. So I work at a company called Blue Sky Analytics as data scientist. As Raghavendra mentioned, I also started my GIS from Ujaval Gandhi. Whenever I listen, there is something to learn even after using QGIS for so long. So thank you Ujaval Gandhi for coming and teaching us again about the workflows.
Myself, Raja Sirajna. I'm working as a senior data scientist in company. Nice to meet you all.
My name is Santhosh. I work as data scientist in NDC. We work in the agriculture domain.
Hi everyone, myself English. I'm working as a project associate in Geospatial. So we work primarily on the public health domain. So right now we are trying to get into other domains such as the climate change and apart from the public health. So this is the first time I'm attending this talk, and looking forward to it. Thank you.
Hi everyone, I am Amrut Kiran. I am a senior faculty at the Indian Institute for Regional Settlements in Satyukt. I'm also the last co-organizer for the group Jordan probably didn't see me after this day. But thank you everyone for coming. This is the 7th event. Do check out the links for all of our content that all of our speakers will be putting across the website, the Slack, the LinkedIn, the Twitter. We need more followers on YouTube because we can't stream directly on YouTube unless we have 50 subscribers, so we're not 50 yet. So please, all of you, if you could subscribe to us, maybe the next time we can have direct YouTube streaming to be easier. So yeah, I just wanted to say that. But thanks for all coming here.
So I am Santhosh. So I am a civil engineer basically. After doing my civil engineering, like I was working in a construction company. Then I got interested in the geospatial domain and joined my masters in Anna University. While doing my masters, I really got blessed or lucky to work with Ujaval. I joined Spatial Thoughts. COVID happened and he went online, so it was easy for me to work with him. And working with him for 2 years, I joined Blue Sky Analytics. Now me and Aman work in the same company as a data scientist. My work currently focuses on the carbon stocks and mostly predicting peak counts like that. So I'm a data scientist in the geospatial field. Okay, thanks for the introduction. I also want to let you know that moving forward into this Let's Talk Spatial, if you want to give any speech, do reach out to us. We are always looking for speakers who are expert in a particular domain. Or if you are novice and want to explain your techniques to our participants, you can reach out to us. And if you are in a company where you have a big space and you're liking to host us, do reach out to us. We are looking for space to host every time. So since we are making this event for every month, we are just looking for a space to have this event. So that's not. And I also want to point to people who are just starting in QGIS. So there is a website called QGIS Tutorials, which is also maintained by Mr. Ujaval Gandhi. So he is the author and it's maintained by Spatial Thoughts. So that has some very basic steps to start into QGIS. If you are looking into beginning into QGIS, you can check out that website. Okay, so now let's move to the next hour of this session. So Mr. Palanichamy. So Mr. Palanichamy is a senior manager in geoanalytics at WRI with a postgraduate degree in Earth observation and geoinformatics from IIRS, and he is actively participated in various research projects exploring the spatio-temporal variations of geophysical and anthropologic phenomena. He has also created multiple machine learning models to predict urban and water resource management in India. Today, Mr. Palanichamy will be presenting in the topic of data-driven decision making, applications and limited in GIS. We are honored to have you here.
Also wear it.
Is it fine?
Can you keep it closer?
Is it fine now? Is it any better?
I think you can keep it closer.
I think this one doesn't use the body area.
Just
Thanks.
Yes.
Okay, sorry. Sorry, my voice is out. I couldn't speak much. I was doing a session on Earth Engine yesterday. Entire day session. So it was really hard because the problem with that session was that there were people who have never done programming in their life. There were people who have never even heard of remote sensing in their life, and they wanted to learn it. And I had to start with Earth Engine. So it was a room full of 75 people, so you can imagine how it went. It took 3 hours for me to complete 2 time periods in DVI images. Like, that's the difference of NDVI images in Google Earth Engine. Right? Like we talk about how fast it is. But it took 3 hours. So you can imagine how it went. So anyway, so my voice is a little bit down. I'll directly go into the presentation, and before going into the presentation, I'll just say it's completely different from what Ujaval was talking about. Ujaval is the god of QGIS and Google Earth Engine, so he talks about methods and the best methods. Of course, there are many ways to skin a cat, but usually his method of skinning a cat is always better than everyone else's. So, I've been loving his work all through. But mine is a little bit different because of the domain I come from. So I'll explain where I stand and what it is. So basically, this is not going to be a very technical one. This is going to be, you can consider that as a rant, you can say, on GIS and remote sensing, right? Like, so this is all based upon, particularly in my experiences of working with the governments in the last 8 years. Anyway, so I call it as the data-driven decision-making process. There is, you have lots of these data, spatial or non-spatial data, everything that comes into your hand, and you want to convert that into an insight, and eventually you need to influence policies and decision, right? Like, so over here, I rarely talk to GIS professionals. I rarely make presentations to them, right? Like, my usual audience is government, or it could be students who are pursuing GIS. I rarely talk to my fellow GIS professionals, so I don't have anything about like what is the methodology in which I implemented or anything around that. But if you have questions around that, we can have that during the discussion. So what is this data-driven power? Oh,
Just to
any better?
Yes.
Okay, great. Right. So before going into that, I'll show this news article from MIT website. I'm not sure how many of you have seen it. It's a project to use aerial images and machine learning to classify footpaths in the roads, right? Like, so to figure out what is the footpath, road crossings, etc. So AI for AI over aerial images and to create this data. So sounds cool, right? Like, how many of you are interested in it right now to hear about it? Okay, good. And I'm not going to talk about it. I'm just saying, like, how many of you are interested? Just wondering. Next is the empowering the MP. This is an article that I found last week or something. Maybe I'm not sure. I forget a lot, but maybe 2 weeks. I don't know. But it's a brilliant article. It talks about why spatial data has to MPs need to know about their constituencies more, and spatial data can provide lots of information that is required. So, for example, in particularly with respect to healthcare and education and all those things, so MPs need to have that data in their hand because they are really powerful people, etc., etc. This is also sounding cool, right? Like, this is a brilliant idea, I can say. But anyway, I'll talk about it in the end, and I'll talk about what WRI India is. So WRI India is an organization that is focused on research to action. So what you're doing right now is research. You have to convert that into policies and insights, of course, and figuring out what is best for humans, right? Like, so what is best for livability, what is best for environment, and what is best for economy, and that is what WRI India does. So this GIS and remote sensing is a component in our work, but it is not the entire work. And you have to have that in. And that is where the reflection is going to come from. And we are in multiple countries, and we are having an office in Bangalore also. So if you want to go and check what they are doing, you can do. But rarely people come, but anyway. So then I am part of the geoanalytics team, and when I started out, it was just me. There was only one person who was doing it, and later people like Raja, for example, he worked with us in WRI India. And then after that, now we have 3 folks in here, but right now the team is actually around, from 1 person it has gone to nearly 20 plus. And core team has 20 plus people, and we have around another 6 or 7 focusing on GIS applications. And how this expansion happened, I love to brag about myself, and I'll say that it was my success that created it. So what we do is that we want to make sure that cities, since initially I was focusing a lot on the cities programs, that's why the vision statement is like that. But we want, instead of cities, you can make it as government, but we want governments to make planning and governance decisions based on, lots of these data analytics and tools, but while being, economically competitive, environmentally sustainable and equitable. So these are our goals. It's very simple. It's not just that I want to do this analysis and I want to dump it in the file of a government officer. That's not the motive. So how am I going to influence the life of another person? Right. So typical process. What do we use a lot of these things, GIS, remote sensing, and all those things, and then we do researches. See, in particular, for example, I put it as what we do as prototype tools. I am not my colleagues know it. I don't like building apps, even though I'm initially 10 years ago I loved to build apps. 10 years ago, I loved to build websites. now I don't like building any of those. I don't believe in it. Instead, I mean, I don't do it. And it doesn't mean that I'm not asking others to not to do it. But we build prototype tools. What is that? Is we are not running a parallel government. We want the government to develop everything. We are just a knowledge provider, right? Like, so we provide this knowledge how to do it, and what is the best way to do it, and what is the best kind of information. But mostly I focus on research and how it can lead into planning process and governance decision making. What is that decision making? What does that mean, right? Like, so since I love maps a lot, there will be lots of maps in my work. It has always been like that. But it doesn't mean that we have been only dealing with spatial data. We have been dealing with non-spatial data. So this is a very old photograph of how we were doing a master plan for Chikbalapura. It's beyond the app. I mean, if you go in the airport road, it's another 1 hour maybe. So we provide a lot of these maps. We develop insights, and we sit with the stakeholders, trying to figure out what works for them. Right, like, and trying to figure out, I mean, see, data is always filled with a bias. You have to remember that what you're having is a remote sensing or GIS and everything. If you believe religiously that this is going to be representing ground, then you're highly mistaken. So you have to be very careful about what you're going to. So I usually call ourselves, the GIS fraternity, as the AC room folks, right? Like, so rarely having any touch with the reality. Talk about everything from our computers. We think that everything is within the computers, and we believe that. We honestly believe that, right? Like, so there's a savior mentality within us that we know everything and we want to save others. But always a data-driven decision-making process will be like, I have data, but I also want to know what is coming from the ground, what is there on the ground, and what do people really think about it? What are these really things that I should be focusing or not focusing, etc. So of course, this is a very simple one. So how we start is very simple. We start everything. I mean, in WRI India, we work on almost every single issue that you can find environmental related. Whether it is, for me, the topography map, I begin with that because that's where the land is, and from the land, I mean, we try to. So in Mumbai, for example, we are doing flood modeling, and we are closely working with the Mumbai Municipal Corporation, trying to figure out which are the clogging points and what you should be doing, etc., etc. So you can see where it is coming from, right? Like, so we have to develop high accuracy elevation models. We have to figure out where the buildings are, where the built-up layer is, where is the water moving, and how much you can do. For example, if you want to do rainwater harvesting, if you want to do any other activity that will reduce surface flow, for example, that is one thing that. And of course, monitoring urbanization is a key application. Or it could be anything related to surface temperatures. This is one of the biggest buy-ins that we have right now, and because every city government wants to know which are the hotspots within the city with respect to their rooftops, with respect to how much vegetation that they have, and the simple correlation maps between vegetation and land surface temperature actually hits the nerve a lot. I mean, they'll be like, yeah, I want to focus on this. I want to prioritize which areas to do this. So I mean, if you want to know how much useful it is, so we published this land surface temperature map for Mumbai 3 years ago or 2 years ago or something. I don't remember when it was, but one newspaper article took it. And the next day we had the call from the then environmental minister of Maharashtra, Aditya Thackeray, and he called and he said, Mumbai has a lot of these problems and you seem to have a lot of data, and you have the capacity to do the analytics and eventually the solutions. So why don't we work together? And one thing led to the other, and Mumbai became the first city to have a climate action plan in South Asia. And so you can see where it is coming from, but started with the data, but this is not the only thing that is there in the climate action plan. If you go and look at the climate action plan, you will find maps here and there, right? Like one or two over here, some of them pushed into appendix and annexures, etc. See, data is enabler, data is not the solution, right? Like, so with data, I'll be able to understand what's going on, and it ends over there. It's, providing a website or providing a data source is never the solution. So it can be an enabler, maybe it will work, maybe it will not work, so we have to be very careful about it. So of course we worked on the same concepts, we worked on different land uses and tried to figure out which areas that you need to focus on, prioritize and everything. Because for us this is very critical, right? Like, so I was mentioning environmentally sustainable, yeah. but equitably. So I'm going to deal with, on one side, slums, on the other side, privileged folks who have good amount of building, good amount of greenery, a very different urban form. So how do I design policies for these, and how do I identify these differences? That is the questions that we try to answer. And we try to take all this land surface temperature, whether it is the urban form, any form of road networks and everything, we try to correlate it and see it, how it works, so that we can develop insights out of it. And or it can be an easy task. For example, this one is another one which is for roads. I mean, we just wanted to figure out roads is an actually easy place to do interventions with respect to greening because government owns it. So it doesn't mean that it doesn't have other complications, but it is the easiest of the entire bunch. So we wanted to figure out which are the hotspots in the road, right? Like, so it's a very simple task, which is over concretized. So directly it goes into that. Similarly, coastline assessments, etc. Like, I mean, how coastline has changed over time, and right now we are building a more robust data set actually that talks about how coastline has been changing both the high tide level and the low tide level over the last 30 years using Landsat images, Survey of India's tide gauges, tide models and tide observations from ports and everything. We are trying to figure out a complete model. Half of it will be done in Google, I think. But so I mean, one thing was because in a climate action plan you have to deal with this coastline is a very, very critical thing that people always talk about. If you had read my tweets, you would have understood a little bit that any of those visualizations that you had seen with respect to coastline, sea level rising, and they just put a elevation model and they just say 1 meter means these many people will be affected, half a meter means these many people will be affected, these many infrastructure is done, etc. See, these kind of models, when it comes to me, usually what happens is that I'll push it out as garbage, right? So that is actually, this is the kind of thing. So that's what I was saying, as GIS engineers, GIS data, remote sensing data, these are all one thing. Ground reality is a different thing. So usually the problem is that for understanding and understanding and also for modeling coastline changes, you need to talk a lot about longshore drift. You need to talk about the sediment transportation, etc., etc. There is a likelihood that increasing sea levels can increase the land area actually, and in many places in South Pacific, actually, researchers have found that the area has been increasing, which is contradictory to the common perception, right? If sea level increases, land should be decreasing, but that doesn't work that way, because if it is a storm surge because of a cyclone, then there is a possibility of land, water coming into that letter, which is a sudden change. But 100 years of change will not work that way, right? Like, so it is because of longshore drift, there will be more sediments coming in, and there will be sand accreting, and there are so many problems associated with it. Not just one. So, groundwater, that's a different story, but majority of these people, this show all this, I think Climate Central or someone published it, and I had to write a massive rebuttal against why this has to be. Now, why is that a problem for me? Now, those agencies, those guys who are showing these maps are telling you to prioritize on a different problem, which means government is going to spend money into that problem, right? So, and they are going to push people out of those, what they claim as vulnerable areas. Imagine the social and financial cost to it. If I'm going to tell you that your place is going to be flooded and you have to move out, imagine how much cost you have to go through, right? And when that data, when the base data that says that your place is flood vulnerable, which is, if it is a questionable one, then what is it, right? Like, so how bad it is, right? So for me, it's very important that I have to be responsible. So the quality of work I usually see from WRI India is that, personally I try to make it as much as possible, is that 50 years later, still the WRI India geoanalytics team is accurate. There cannot be a question mark in the analytics that we produce. And no one can say that, WRI said this, because of that we did this, and because of that we are now facing this problem. That cannot be, because WRI India is actually a very, really powerful organization, by the way, right? So, including myself, we have so many IAS officers, politicians, and everyone in our touch. We are not elected by the government. So, and I have tons and tons of GIS data that is not there with both the government as well as the other private organizations. So I have that responsibility to produce the right analysis. So that responsibility should be with all of us. It's never about the methodology that you use, it's never about the methods that you use, it's not about QGIS, it's not about ArcGIS, it's about what you produce. That is actually very, very critical. And anyway, in planning, of course, the spatial expansion and all those things, we use a lot of remote sensing. But is that enough? Right? Like, so, yeah, I know that South Bangalore is growing, East Bangalore is growing, whatever. Is that enough? So, you have to know which agency is going to use this kind of information. It's a beautiful data set. All we have, DHSL is there, WSF is there. You can also classify and you can produce it, but what agency is going to use it? Just think of it. Like, how many of you, just think about it. How many of you have actually bought for your personal or any other purpose like a GIS or a remote sensing product? You won't buy it. There's no consumer for it. Most of the consumers are actually government. Only a select industries where you have navigation or crop oriented stuff, there you might have a small amount of possibility that there is a private vendor for it. Private consumer for it. In other things, it's not. I mean, for example, who is going to require this map of spatial expansion? So only government. So you have to think about it. And when I produce this map, the next question comes up like, yeah, you are saying the right thing, but what does it mean for me? I have to create more information out of it, like how the road networks are there, how services are there, and what it means. For example, one derivative. This is one just a small derivative. This one we did it at a national level. This is a very old one. We have an updated one, but what it is I wanted to figure out how much of the growth is happening along the highways, how much of it within urban areas. This is a very old one. Amran, others also working on a little bit of a different version, but there is another version also where we are trying to figure out how much of the growth is happening along highways, how much of the growth is happening outside the municipal corporation along highways, and how many of them are triggered by SEZs, how many of it is triggered by an industrial cluster that you put, how many of it is triggered by a new highway that you build. Why is it important? Take a look at the new road that has been built in between Bangalore and Mysore, or the new road that is coming between Bangalore and Madras. So it's going to trigger development in some places. It's going to make other places degrow. Some places will lose growth. Not just lose growth, they will lose business. Chennapatna, for example, it has been long dependent on people crossing the highway, and they just sell their toys and everything. And so now we have to figure out how much of the growth is happening along these highways, how much of it is happening outside, and how much should be triggered. What is the economy behind it? And now that is actually critical for us to come out with a regional master plan, etc. Now these two roads, for example, they do not follow any master plans. They are just infrastructure projects. They just get the money, they just put the road, and that's it. And no analysis of what's happening over here, there, etc., etc. It's very difficult for us. In the long run, it will be a problem. We want to give an example of a long-term problem. Outer Ring Road in Bangalore. They developed one road, that's it. They didn't talk anything about the area around it. Now you have traffic-related problem, now you have flooding problem, now you have heat-related problem, you have security-related problem. Everything is there in the Outer Ring Road between Silk Board and Thiyaku. Can you disagree in that? Like, there is nothing. So for us, it's very critical that what triggers, etc. So we began doing machine learning algorithms, trying to figure out how much of it is highway growth, etc., etc. So for us, if you maybe I'll go into that a little bit deeper, but and also future predictions, etc. So this leads to the next part of my presentation, which talks about then how do I decide what should I analyze, what should I model. So for me, there is this, my colleagues know it, but I usually keep it in the 4 sections: purpose, science, technology, and art. If these 4 are not there, then your project is simply useless in front of a government. This is as frank as it is. Otherwise, it's all going into the archive and everybody will forget what you are doing. You have to answer all these 4 questions, and there is a weightage for all these 4 questions. Usually I put purpose in the number 1. Why are you doing what analysis that you are doing, and what is the purpose of it? What question that you are answering? Like I said, are you answering a planning question? If it is a planning question, are you answering it for BBMP or BDA? How are you working? What, like, is it like you have brilliant models to show water flow, or you can show how building is growing, or this, that, etc., etc. What does it mean? Why do I need? Like, for example, if I have to put it, you can have a brilliant technology to count all the hair in my head. Is it useful? What is the purpose it's going to serve? You can have an amazing technology. You can have an amazing methodology. You can have sensors all around you. You can put thousands and thousands of crores into it. Doesn't matter. So you have to answer the question of purpose first. Why are you doing what you are doing first? Usually I give 70% of this. If I am going to score some project, this is 70%. And whenever some project comes to me, I have a very good luxury right now. I don't, all the WRA India maps or the visualizations that you can see outside or something like that, I don't do it anymore. We have these magicians who will do it. I am that old uncle in a marriage, who is sitting in the corner and who will be like, don't do this, don't do that, if someone comes up with something, I'll be saying, no, instead of this, do that. And they would have done an entire process around it, and I'll be like the guy who's putting a roadblock to it. So that is my role right now, and I love enjoying that. But anyway, 95% of the time when there's a GIS project or remote sensing project that comes into my plate, I have a tendency to reject it. So remote sensing and GIS is one of the most overrated industries. Not as much as AI and ML, but it is close to it. Right? Like, so everything requires a map. Every small thing requires a map. Of course, I'm like a devil's advocate in the room, right? Like, so I'm speaking everything against the common perceptions in this room. But that is the reality. I see, I'll go into that at the end. But anyway, the next part is science. Science is another thing that many of us don't focus on a lot. Why I'm saying is that when compared with technology, usually everyone's focus is on the technology, the coolest technologies. I have this ML algorithm implemented in that. I have this massive, big Python code, automates everything, and that is the thing that you focus for 95% of the time in your project. How to implement and how to do that. And that's where I contradict a lot. For me, it's just 5%. It doesn't matter. I'll go into that. And the next one is art. This art is something that I never believed in when I was when I had graduated out of college. When I was out of IIRS, I was no different than you. I'm not saying that I came from a different thing or something like that. I was exactly majority of you when maybe 10, 12 years back. I was the same. I wanted apps for everything. I believed that if I open data up, world will be richer, world will be poverty will be gone, environmental sustainability and everything. That's all gone. Now that art also is the same thing. I always believe that science and tech is the greatest thing, and I had the power of it. Raja would know it, and when I was studying actually. So I used to be the guy like whizzing all around with beautiful Python codes, this, that, etc., etc. But I never thought art was important. I never agreed that GIS had an art component to it. But it was art that did the thing for me. It was always art. Why I'm going like, see, you can have thousands of thoughts in your head, but how do you convey? I'm not the best at it, but I'm just going to say that how do you convey that thought into another person's head? You have so many maps that you are preparing in your projects. How do you display it? Has anyone come to you and said that your map is good, and the moment I saw it, I was able to understand what you have done? See, these are the questions. So that is very, very critical for me, because I work with the government. I'm not working with another GIS person. I'm not working with another field expert. I'm working with a government employee who is going to have a very short time span. Right? Like, so he's a typical government officer. Actually, of these days, I try to replicate myself as a typical government officer, because 7 or 8 years back, what happened was I went to a meeting and I was like treated like a college student. Like, you do not know anything, why are you here, etc., etc. And ever since that, I think this is a very rare meeting that I'm having a non-checked shirt. So I began changing my looks for making sure that I don't look young. If you are looking young, if you feel that you are looking young, take a remote sensing project and go to any government office and come back. You will know what I'm talking about. So I began increasing my weight. I began wearing checked shirts. Usually I have more hair in my face, and I tend to, the basic idea is that the buckle should face the ground. The belt buckle should face the ground is the common thing. And I should look like a typical South Indian government officer, right? Like that is the look. And I changed my mannerism also. For example, folding the hands behind and having tea. I don't even like having tea. And I had tea because I wanted to have these things on. So it's all about art and communications. How do you do it? First, they have to feel it that this is theirs, etc., etc. I can go on. But anyway, purpose, for example, for us, like I said, the surface temperature, it's very simple. I wanted to talk about greenery. I wanted to talk about building efficiency. And I wanted to find areas that I can prioritize. So I began using surface temperatures within urban areas. For example, on one side you have the buildings and overlaid on surface temperatures. I wanted to talk about what materials that they are built on, what is the, how much tar you have, how much concrete you have, and how much you can reduce the heat from it, and how much you can increase vegetation. Of course, I'm not talking about nature. It's not about nature. The trees, every tree that you plant is an artificial plantation, right? Like, so it is not nature. It's just a offsetting mechanism that we use to offset the impacts that we had created, right? Like that's it. I don't believe in greening every part of the country or every part outside, even even in the peripheries. I don't prefer planting trees. So like as much as natural ecosystem is possible, it should be. Just because it's green doesn't mean it's natural. But anyway, science. So this is where many of the people I have seen going wrong. Because first point is very, very, very critical. Geospatial data is about representation of ground reality. It's an abstract of reality. Now, even yesterday I had the same problem with the SET university students. I had asked a question, very simple question, like how long have you been here in Ahmedabad? Some of them replied like 3 years, some of them 4 years, a good number of them 6 years, 8 years. And then I asked them some questions like where do Dalit people live in your city? Where do OBC people live in your city? Where do upper caste live? Where do higher income people live? If I talk about a particular neighborhood, say Jayanagar, is it upper, middle? What income? What ethnic group did they belong to? What is the type of job that they go into? 8 years you have been into planning industry, you have been into data analytics. If you are going to talk about interventions in your city, you need to know about the city, right? So for me, it's very, very critical that your data should talk about what is there on the ground. Otherwise, what will happen is they will take some census data, or they will take some projected data, they will take some sample surveys, all those things, and they will say this, that, etc. All people in Jayanagar are poor. Some survey would have come in and etc., and they would have, and that's going on a lot actually. There is a lot of data quality problems in India than you can ever think of, and the problem is people who are like us, the GIS engineers, without fearing the consequences of it, they take that data and they start processing it, and they give the wrong information and insight. And this severely affects, as much as lack of information is a problem, the lack of right information is a bigger problem, right? It's, if you provide a wrong insight, it's going to be very hurtful. And so I have to be very careful. So you have to understand that geospatial data is about representation of ground reality. Every point of information, when you create it or when you have processed it, you have to cross-question whether you have got it right. You have to understand, you have to know your localities very well, you have to know your study areas very well. When I was focusing a lot on Bangalore in the first 5 years of my work, I used to travel randomly also, and I used to, there was a small period in time when I didn't, but most of the time I was trying to figure out where are these people, where are they going, why are they there, etc., trying to figure out the data that I had in my hand, whether it is matching the reality and whether it matters, whether my analysis is true or wrong, and I can't be wrong, and that is where it is coming from. And always do exploratory data analysis. Everyone gets the data, yeah, this is coming from a trusted source, this is published source, immediately use it. It's like without doing any exploratory data analysis and anything around it, like trying to figure out what is maximum, what is minimum, why is it maximum, why is it minimum. So I saw like a few weeks ago, I think I saw one employment data and it gave some random results. And then my question was very simple, like, did you ever do a search on the other side and try to see whether this data could be close to reality? Maybe you will not be able to accurately say it. For example, if I am going to say Jalandhar is famous for its textiles, Jalandhar is having a very high number of people working in textiles is something that the data is coming from. I have to check whether it is true or false, because it doesn't mean that I can directly go into it, and nobody is doing it. I'm so sure that most of the GIS engineers, the moment they get the data, they are happy that they got the data, and they don't worry about the quality of it. And as I said, incomplete data produce incomplete analysis and could be harmful. So don't practice ever that saying that this is all I have, this is all I have, this is all I will process. That is not there. What matters is your reputation. What matters is the quality of your analysis, not the availability of data. That is not the problem you are dealing with. So you have to always remember that when you are dealing with a problem, you have to ask this question, what is the problem that you are dealing with? Whether it is a problem of the process or whether it is a problem of the platform. Which means, is lack of GIS data is the problem, or is it something else? For example, I'll give you one. So this happened in 2020 to 21, 22. What's the last year? Bangalore flooded. I was in so many news channels at that time. I think around 5 or 6 channels had interviewed me. Some of them, I was in the debates and everything, NDTV debates, and so many things. And I had to bring the geoanalytics side of things, GIS and remote sensing side of things. Very simple flood analysis, everything that I have done and all those things. There was this, in a debate, they also always try to bring people from the other side of things also, right? Like, so they brought one IT guy, the breed that I don't like right now. So the IT guy said, what is the solution for flooding? And here I am, having researched the subject, trying to figure out what is happening and all those things. And I tried to make as simple as possible. This was News 6, News 6 channel. The person said, why don't we implement a blockchain for it? And blockchain for figuring out who gave the permission. I was like, what is the problem that you're dealing with, right? Like, so do you have any understanding of the problem? Right? Like, absolute no relationship between the problem and the solution that you're proposing. Immediately the answer was like, wow, this is why I love Bangalore. They are all bringing technological solutions. And I was like, shit. And I had to come back and I had to, say something. I don't remember what exactly I said, but I said that it was a stupid idea. Something I said. And then the person said, no. And I said also that these are knee-jerk reactions. Bangalore's urban problems are really long-term ones. We have to figure out what are the long-term solutions. It's not bulldozers or it's not those kind of things. You have to think about it a little bit too. And they said back, like, it's not knee-jerk reaction, etc., etc. And I had to respond back saying that, let March come. I'll be the one who will be running around for flood-related issues in Bangalore, and none of you debaters will be there. And it's true. Even now, I'm the one who is going to offices once in a while, trying to figure out what's happening, and nothing is moving anyway. But I'm just saying, like, that's what the reality is. So, why I'm saying is that you have to understand whether it is a problem of the process. The process is the problem, not the platform. It's not blockchain. Why won't a person who is able to manipulate paperwork will not be able to manipulate data work? It will be even much easier. It will be even monopolized. So, who is going to stop it, right? Like, and how will an ordinary person be able to find out a problem? At least papers, 80% of the population can read. And you have a blockchain technology, how many percentage of the population will be able to read? You are actually adding more risk to it. So anyway, you have to understand that this is actually a very, very important part, that data collection and data, figuring out what is the quality of the data and whether you are actually talking about the right things. So dedicate your time into it. In wrestling parlance, we call it as the putting your time. So meaning that I once asked my colleague to digitize 12,000 polygons. Sit and digitize 12,000 polygons. I know for sure, like many of you would be like, moment I say that, they'll be like, how will I auto trace it? How will I automatically convert a PDF into a vector file? I don't like it. Why? The moment she started digitizing, she began realizing what are the problems that were with the data that she was using for digitizing. When she was digitizing, she found out that there were some codes that were, not looking right, not looking wrong, and she was trying to figure out what is going on in the back end, and she began doing it. That is putting in the time. The moment you do that, without knowing that if you auto trace it and everything will come, it will look like a very smooth picture and you'll love it, and immediately you'll understand the analysis. The insights that she produced that day while digitizing, actually it was very, very critical for us while we were writing the national urbanization policy. It was actually a very, very important task that I can't reveal it right now because of the confidentiality things, but it was very, very important. Right? Anyway, like I said, methodologies, don't always go with the coolest methodology. Try to figure out what is the right methodology. And it also depends, for us, it's actually dependent on resource efficiency and reproducibility. So the reason why I love using QGIS and everything is that the moment I do something in QGIS, a government official is going to replicate it. They are planning to replicate it. And I can't impose the cost of ArcGIS on them. And it defeats the entire purpose of why I am doing it. Right? So that is the reason why I am always thinking about resource efficiency and reproducibility. Technology, I always have this slide. If all you have a hammer, everything looks like a nail. The moment you know Python coding, everything looks like a Python program. The moment you know Earth Engine, every remote sensing problem is a Earth Engine problem. It's the same with GIS. The moment you see a spatial data, you think that spatial data will be the solution for every problem. So don't get attached to any tool, don't get attached to any methodology. See what is the purpose and see if that tool is going to fit. For example, I love QGIS, but this map was created with Excel. It's an Excel visualization. So does it matter whether it is QGIS or ArcGIS? All you want is information to be conveyed. There is a very Excel, of course, is arrays, right? It's just color formatted, and it got the result. This slide I kept it because December, I think I was invited for a talk on machine learning in not exactly data-driven process, but role of machine learning in climate change. And imagine an organization had to invite me thousands of kilometers to talk about this. Right? So it was in Delhi, I was in Bhagat near Kanyakumari, and I had to fly in over there, and I had to talk about role of machine learning. And I said, in a data-driven decision process, you have data which you need to convert to information, and then you have to create an insight which has to eventually go into a decision. And I put a large box over there because the slide deck, when everyone wants to see it, it should appear, right? Like that, just for the visualization sake. I told them that the potential role of machine learning is absolutely nothing. It's very small. Linear regression is more important than machine learning. A simple linear regression or a simple count or something like that. And then I told them nobody ever called me for a presentation on Pearson correlation coefficient and its application on climate change. Nobody asked that. It's just that these kind of technologies are becoming fancy words. This is just staying in the room. I know that in this room there is no donor over here, right? There is no venture capitalist over here. So this is for you. So it doesn't mean that you apply it over there. You just know it. Okay? When the donor comes, I'll be like, yeah, you can do a machine learning problem because give me money, because that's where the money is.
I think that is the problem. There is a problem also.
Yeah.
There is a problem.
So,
government is putting one solution. They don't want a solution for agriculture. They say they want a solution for agriculture.
Yeah. So the thing is this. So I tried my best to deflect all these projects. So they were like, if Raj doesn't do it, I'll find the person who will do it. And the thing is that at least in my guidance, it can be a little bit more responsible. So I try to. But that is the reality. Everything has to be even. This was November. I got a request for a machine learning model, and I asked what is the data set that they had. They were like, concepts were all there, but I asked what is the data that they had, and what is the potential of that data. 36 rows. 36 rows. 36 rows of data and they wanted to do a machine learning model for it. And I was like, a simple chart will do it. No, but the donor is asking us to put in machine learning. I was like, how would you put machine learning model with 36 rows and you have like 24 columns or something like that? And how? It's not mathematically possible. They are like, but they found the resource who will do it. I didn't do it. So anyway, so I talk about this a lot. Do you need complex machines for solving simple problems? Do you need that machine? Say for example, this is that 1930 cartoon. Take the spoon, it will trigger something, it will trigger something, it will trigger something, and finally the napkin will wipe your face. Why is that critical? Remember the first application that I was talking about, MIT's aerial image identifying platforms. Do you need that? That's the question. How many times can you run drone images? What is the cost of it? That's my next question. Cost is okay. What is the budget of the municipal corporation that has to deal with it? And Bangalore is rich. You can put in, its budget is 6,000, 7,000 crores. My town has a budget of, total budget. I'm talking about every employment and every construction that you have to do. For that they put in around 25 crores. And within that 25 crores I have to employ 2 crores for this. Where will I get the money from? And whether it requires it. You have the question of trees, how do you deal with it? There are so many question marks at the end. Anyways, the planners are supposed to make they have to go on ground and record it. Record it. Why do you need all these ML algorithms? Why do you need to fly aerial ones? So the thing is that, do you need complex machines? Do you need complex solutions is something that you have to always think about. Just continuing on this one. This is XKCD's cartoon, and I'm not sure how many of you have seen XKCD's cartoons. So Randall Munro, I love his cartoons. So in theory, you want to automate it, you'll write a code and automation takes over and you'll have a lot of free time. But the thing is, this happens with the website development. I think Vaibhav, you had asked me a question about once about why you don't get interested in web development and particularly with respect to WRI and everything. The thing is that I'll develop a website today with the data I have and everything. Let's assume that I have done something. Then comes the revisions, this, that, maintenance, and at the end of the day, nobody will be using it also. And the cost I have to do. And finally, the thing is that I'll be so much invested into the technology, that so much into how I should build a website, rather than how to solve the problem for which I was starting to work on. Right? Like I'm focusing on water resources, and I'm going to build this massive dashboard. Every day I'll be thinking how to update this dashboard, how to maintain this dashboard, how to do this, etc., etc. And totally I forgot what is the issue that I was working on. So that is the reality. And have you seen a government website where, not just government website, I'll say how many of you have seen a remote sensing or a GIS method being, moment someone sees that, forget WRS work, forget map work, moment someone sees that, they're like, wow, I was looking at the world wrong, you opened my eyes. Now immediately I'm going to change the law based on that. How many of you have seen that application? So you have to think about how you influence people. For me, that website didn't help, but that infographic, that land surface temperature infographic, it helped. So think about it a little bit. That's where the art and communication part comes in. Producing wonderful research is not the thing. So the reason why I don't have any methodologies of what I do, how I do, etc., is that that's not my fundamental thing. When I go to the government officer, that's not what I want to sell. I'm not selling about my qualities of my skills of QGIS, and it's not about Python, it's not about Julia or whatever it is. It's about what is that problem that I worked on and what is the solution. And for that you have to have a beautiful set of maps. Without a good amount of infographic and message conveyance, it's very difficult. This is a very simple, this is a personal maps. I am just putting personal maps because I have more flexibility in my personal maps than the WRI ones. Because in WRI ones you have to have the template, logo, etc., etc. So, but still you can find a lot of this online. You have to convey the information in regular manner. So here I just wanted to talk about wetland reclamation in Kerala. This data I was working on it because one of our teams was working on the wetland and how crops and everything is there in Kerala. And very simple one, I had to tell them that it is all reclaimed land. It is not a natural wetland. It was earlier lakes and swamps, and it has been converted into cropland. And I had to do a mapping of it. So you can, moment you see it, you will notice which are the areas that you have to focus. The black is the one that has been converted prior to a certain date, and yellow is one date, and red is another date. Simple information. See, this is all the government officer needs, and very simple. This is just for fun, but trying to talk about Nilgiris Mountain Railway. Google Earth has an amazing 3D tool, right? But can you make this information very clear over there? A single railway line. It's very difficult. So be minimal, be a little bit more artistic, and do that. So here the case I wanted to make is that the municipal corporation and urban areas are different things, and that not necessarily the municipal corporation will cover the entire urban area. Very simple. How much information I have to put? Look at it. So I had to add a river in between. Why did I add a river in between? Otherwise there will be a gap. See, the moment I show a map, you shouldn't have questions. You should have insights. I'm going to sell my value to you. If I put a gap over there for the river, it would have looked like grey inside. And people will be like, why there is nothing in between? What is wrong? And I can't leave you with the doubt. I have to provide the insights. My insight was, corporation boundary is not the same as the urban area, and it differs. In some places it's like urban area would be like 7-10 times than the corporation boundary itself, and that is the thought I wanted to. Why it is required? How do you plan for the area outside? What is the planning? How do you service them? These are questions. Do different types of visualizations. Think about it. Think a little bit creative. The same thing that this is the same visualization that you might see in time-lapse animations, right? So instead of that, I used a color pattern, and it was very easy for an officer who is just going to see printouts. Sometimes lack of information is also an information. So I use this as a political one. This is a very personal map. I wanted to talk about elections in Tamil Nadu, that urban local body elections were not happening. This was long back. Not long back, the previous government. So they didn't conduct elections for so long. And I wanted to tell them, wanted to tell it in a funny way and through maps. So the map is urban local bodies with elected mayors and councillors. And the map has nothing. And the legend has another legend, which is a Tamil comedian, which says that pocket there is nothing. Information conveyed, it was having 500 likes on Twitter, and it was passed on very quickly. See, I didn't have any text to put, just put this out, and I got the message that I wanted to convey. So think about it. So are your maps making sense? So there are many ways I think about it. Usually I say that if my niece can understand my map, then there is a possibility that there is a success to it. If not, it is a failure. That is very simple about it. Another is I love wrestling. Most of my maps actually have, not just maps, my art and everything has been evolved with. It's a mix of movies and wrestling, you can say, pro wrestling. I take a lot of inspiration from it. A lot of my words are also, sometimes I make promos actually, WWE promos type of thing, I make it and for example, one is the subtle tributes that I do. And the right side what you have is Bret the Hitman Hart. It was a classic wrestler in 90s, and in 2010 you had this another wrestler, CM Punk. So for a birthday of Bret Hart, he wanted to pay tribute, so he changed his trunks to match his style, Bret Hart's style. So you can see that the pink and black and white, that mix. And I wanted to do this subtle tributes. So the thing is that everyone was saying that Raj, your maps don't have watermarks, and because of that it can be misused or whatever it is. And I don't like adding watermarks because it obstructs the views. So I was thinking about what is the solution for it. And then I thought, okay, maybe I'll do subtle tributes in the map that will make me personally invested in the map. So what I began doing is that whenever I prepare a visualization, I start putting my name in places I know, or I have been to, or I have lived, or I have done something, or I had a friend, or I had some kind of a personal story to it. So for example, in this there's a small name of mine close to this place, right? Shanganasheri, Kerala. One of my classmates, in my class, he was my next roll number. His house was there. So for me, in every map of mine, wherever I put this Raj, Bhagat or R, that will have a personal attachment to it. So now I'm like, I can put watermarks without having the fear that the information is lost. So you can do all these kind of personalization. Maps have to be personalized, otherwise it's not going to be successful at all. So anyway, in general what I want to talk about is the data deficiency and issues around the creation and everything. These are the problems that we have with the government. There is a problem with interoperability. There's every form of issue that you can think of in GIS data that is existing with the government. But the most critical problems that I want to talk about is that there are two things. One is application has not been demonstrated. You always talk about applications actually. You say that with this you can calculate crop yield, you can calculate flood, etc., etc. Is that the real problem that they are having is a big question. You won't find it matching actually. Probably it is difficult for me to explain. It is nobody is interested in a map showing flood affected areas or flood prone areas. It is about the next level of information. That is, in these flood prone areas, what are the unplanned areas, what are the planned areas, what is the something like what is the causality behind it, those things, because they are going to work on solutions. So that has not been done in India. The reason why my team became from 1 to 25, 25 times the growth. The reason is that we were able to find that right application. It's not about the methodology, but the right application. And the other thing is that the other thing that I hate is projects and companies oversell these ideas. Remote sensing in GIS is the silver bullet for everything. Now I showed you another project in the beginning where an MP, you have to bring all the data towards the parliamentary thing. It's a great one. It's coming from some GIS person. And now here's the question. Does it matter or is it important? Parliament is not the place for education and healthcare, particularly at a local level data. It doesn't matter how many schools you have in your constituency. Nobody is going to discuss it. Why? In your constituency, it doesn't matter like you have 25 people, etc., etc. You have to know what is the role of a parliamentarian first. Healthcare and education are state subjects primarily. It's not a national subject. You cannot say that, I need 5 schools in my constituency, Prime Minister Modi, you should help. It's not his role. The parliament is a place where you pass laws that govern this country, and the MP is a representative of you or your location in that place where they make the law. It's called the legislative branch. It's not the executive branch. The executive branch is the one that executes the actions. And particularly when we are talking about the problem of federalism and centralization, those people are coming up with an idea to, bring this data from data government and give the power to the union government. And that's not how it works, and that's not how it should work. Your mayor is responsible for how many hospitals you have. Your councillor is responsible for how many hospitals you have. The councillor is responsible for the roads you have. The councillor is responsible for your, pipes. The MP is not. The MLA is not. There is no point in aggregating that. Now the thing is that now they have sold this idea. In a newspaper, national newspaper, it has been published. How will I sit over there and criticize? It's very tough for me. I already have a very tough schedule. You can ask them, like how many times, if they ask for a meeting, I'll never even give a time. How many articles can we write about this stupidity? But the problem is, the mix between this GIS engineers and the real world is that link is completely absent. That's why I said that people are, now you can understand why I'm saying that these are AC fools. We are losing that touch, and we have to have that touch. Otherwise, these kind of stupid ideas will come out and they will destroy us. Now, of course, I'm being harsh, calling it a stupid and everything, and because I've seen a lot. I'll give you an example. It's recording.
Yes.
Okay, I'll not name the city. The city has a few years back, I just gave the example last 2 days ago. City has elevation model data for a few years back, and the city again, building wise height and everything, the data was never used, and the city, another agency working within the city created another data set for the same thing, replicated it, and they were not using for the purpose that they stated that they would be using. And now they are planning, why don't we collect another data? Okay, third time. Some years ago I worked on another city's work where I had to collate all the information, GIS information, and I had to talk about bringing them into a single repository for government. And we found that one type of shapefile, one data set was there with all governmental agencies with different names, but the data was essentially same. And I was like, okay, how did they achieve the repository? I thought I am the one who is giving them the idea that you should have a common repository, but you all have the same data, and how did you achieve it? Later found out it was the same vendor who sold the same data to government 3 times. Right? So there is this problem. Whenever you sell this, whenever you sell that GIS is great, there is a vendor who is going to come back and say that I can do this for you, and this will be the most relevant one. You can discard the 3 years old one. The 3 years old one itself would be useful in most cases, but they won't let you. So what we have is all unused data sets sitting in government offices, some of them forgotten. I remember once I took some data from one agency's website. The website went down and nobody is having a digital copy even in the government. No names. I do not know what agency you are talking about.
Yeah, I know.
No, but anyway, so that is the reality. So you have to think about it, whether you are overselling it. Every time you oversell it, some taxpayer is going to pay the money. The money that could have been used for education or healthcare is going to be wasted in the contract that is going to be issued for a year. And each contract will have 30-40% commission. So think about it before you oversell all your ideas that you have the brilliant solution. So usually the brilliant solution is not with the technology, it is always with the intent that you are going to go with it. How much insight you can create. So for us in WRI, hence we don't take projects for GIS and remote sensing as sole. So we tie it with another team. We make sure that there is a big team with probably sometimes it's economists or planners or coming from different angles trying to converse, not just GIS folks. GIS will be a component in it, and that's how you can bring some kind of an inclusive analysis. So this is my advice to all of you. As I said, it will not be a technological one. This is all a rant coming from my experiences and my frustrations with the GIS community as such. I'm, like I said, I am devil's advocate in every. Here I have presented about this. Yesterday, amongst the planners, I was the tech guy. I was like, use this method, use this function, use this instead of this function, use that function, etc., etc. So it depends, but I wanted to talk about this to you because I know a lot of you are going to handle a lot of data, trying to create a lot of insights. I thought it would be helpful. The thing is that for me, like I said, art and communication and everything, one critical component is storytelling. I had slides in it, but I don't know if I have the time for it. How much time do I have? I'm over. 10 minutes more. 10 minutes more. Okay, maybe I'll show one of them. See, all of it goes down into storytelling. Again, wrestling parlance. Storytelling. What is storytelling? There is short-term storytelling, there is long-term storytelling. How many of you have actually watched wrestling for like a continuous period of time? It doesn't matter when or no. See, it's never about two people fighting. That is just a, it's a scripted one. People always think always call it as fake. It's not fake. It's not about fake. It's not about being fake. It's a scripted one, just like your movies. And they try to create characters they try to make sure that the characters win over the audience. Some of them they try to make sure that they win over the audience. Some of them they are going to make sure that they look like a villain. The best villains are the best actors usually. So I mean, how can you make people hate, right? So for example, if I sit over here, if I stand, I mean, instead of this presentation where I try to make it as heroic as possible, but if I had made it as all your work is useless and this, that, etc., everyone will be raging with fire and they'll be thinking like, if you come out, I'm going to slap you, right? Like that's the reality. But that's what is building heat. We call it as building heat in wrestling parlance. So why is that critical? If I do that and let's say that I'm saying that your work is garbage, that is garbage, this is not nice, etc., etc. Suddenly Walter from here, he comes out and he thrashes me. Everyone will support for Walter. He becomes a hero because I turned as a villain, right? So that is actually very critical. So a story will have these kind of components and how to win over people so that there is an entertainment value to it, right? Like so. For me, it's always about all these maps have to have a story from beginning till end. You need to tell what kind of story that you want in Kaveri. I mean Kaveri Delta specifically. So now, if I directly go into that social issue or the event that happened 50 years back, you'll get angry or you'll get bored. But so I have to make sure that the way I come towards that has an entertainment value, that you will make sure that when you get it, okay, now it explains and now I am understanding it. That is the concept. That is storytelling. So this is Kaveri watershed. By the way, QGIS to 3JS. So I love QGIS to 3JS. Leave that one. Some of you might have heard of Grand Aniket. It's one of the oldest structures dam, but the fact is actually only the one in the right side is actually the oldest structure, not the others. So what is the story behind it? I mean, that is not the plot of the story, but I am going to tell you that story first. So prior to that, Kaveri is split into Kollidam river and Kaveri. There are three branches: Kaveri, Vennar, and Kollidam. Three rivers were there. It all went in three different ways, splitting in different places. So in that area that I had circled, once what happened was there was a flood, and Kaveri broke its. So the thing is that Kaveri's bed was becoming higher, Kollidam's bed was becoming lower, and which means suddenly when there was a flood, this one broke into the other one, and thus creating in that red area Ullar river, which so now water is not going into the mainstream of Kaveri, it is going back to Kollidam. It was affecting irrigation. So Kallanai was built. Kallanai means stone dam. The first version of it was built 2000 years ago, and to prevent water from going from this side to that side. And then what happened was the British came in. They saw it was because of all this erosion and everything, the water is not moving in the way that you would like, and the irrigation is not going good. So they began building system of regulators, how water will be distributed to each of these distributors. So they wanted to alter one of them so that the cost becomes cheaper. And they altered the course of Vennar, and a new course was constructed, and all of them became like three times it has become now. So over there they began regulating it. And it doesn't mean that it is all proof. So they began constructing a lot of these Kalingulas, and Kalingula is a Tamil word for water controlling structure. 150 yards Kalingula, there was this surplus, etc., etc. They built to move water from one place to the other. They began doing it. This is a heavily engineered river. And in later, what happened was they built a new canal called the Grand Aniket Canal, and they did it at the same place. It started from the same place, thus creating the modern structure for that dam. So you can see that those 5 sections that you saw initially in the image, you can see how it has been changed. Now, what is the thing with this Grand Anicut Canal? It began irrigating places outside the delta, not traditional delta. The traditional delta is the one that you can see in the green, Kaveri Delta. And this old new delta was created by adding this canal, and it behaved just like a river, a new river, and adding it. Now, why that matters is that this is a map of scheduled cast percentage. So, scheduled caste have been in this region, had been workers in those plantations, cropland. And interestingly, you can see in the new delta their percentage is very low. In the old delta only their percentage is high. So traditionally they had been always confined to that. The new delta was with backward caste. They were the workers because it was rainfed initially. And Thevar community over there, one of the dominant communities. But anyway, some of them were there. And SC community in the delta. Now, why does this matter? The SC community, I actually had one more map, I couldn't add it over here. I had land ownership also, taluk level. The SC community did not own any land in the land that they were working in. And there was a peasant uprising long back, and you can Google it for Keelvenani massacre, where protesters were put into peasants who asked for a higher pay were put into a single hut, and 40 to 50 people I think were killed in a single day. Now, why is this a problem? New boundaries of MLA and MP, everything is being drawn. And when they are being drawn, they are made sure that you don't have, one caste, dominating the other or something like that. To make sure that in English it's called gerrymandering. So this is actually very, very critical for understanding that process of gerrymandering. That is, how is your MLA constituency? See, if I MAUP, modifiable area unit problem, if you want to talk about it, if I put old delta into one constituency and new delta into another constituency, you'll have one Thevar and you'll have one SC. Right? One BC and one SC. But if I cross-cut it, what will happen? It will create confusion. And now, confusion is okay. I mean, I'm not saying that it is bad or whatever it is. But how they draw it is to make sure that some of the caste preferences are kept alive. And this has been continuing for long. And now it has been slowly, forgotten because people don't know actually. That's the best part right now. Many people are ignorant about, when I said people do not know about their ground, it's actually sometimes good also. Because you do not know about the ground, they are not doing gerrymandering. So otherwise they have the tendency to do their gerrymandering. So in order to make this statement of gerrymandering, I had to start from that entire thing. So this is called storytelling. Between old delta, new delta, otherwise it would have been like old delta. If I just directly tell you old delta, why are you calling it as old delta and new delta? What is the relationship between them? So you need to have that storytelling aspect. So all my maps, all of the things that I work on will have these stories. I'll quickly go into one of them. It's recently prepared. None of them are analytical products. I didn't even put any of the analytical data that I created. I won't use it in my maps. People don't like numbers. People don't. Government officials can't differentiate between 0.1 and 0.01. If I'm going to, I remember it first time. When I joined WRI, I prepared this LULC and urban classification and everything, and I went like saying that Bangalore's urban area is some 300 square kilometers plus or minus some 24 square kilometers or something like that. I had put it. Now based on 95% confidence interval, it was plus or minus 25, some number I had there. I was grilled 3 days for it. What does this 24 mean? Like, why are you giving me this one? And I was like, because there is a problem with the estimation that can be, sometimes it may be wrong, sometimes. No, you have to tell me whether it is 300 or 324. You cannot say 300 plus or minus 24. So that's the reality. So the thing is that, and does it matter also? This is a question Professor Amitabh Kundu asked me. Professor Amitabh Kundu is the head of Kundu Committee, is one of the leading economists in India.
The guy actually he works in a very funny way sometimes. Actually, you give him an Excel sheet, he will discard it. You have, even if it is having 3,000 rows and 2,000 columns or whatever it is, it doesn't matter. He will ask for a printed copy of an Excel sheet, and he'll look through it and he'll come with insights around it. He's an insane economist. So he asked me this question: does it matter whether India is 33% urban or 34% urban? Very simple question. Valid. Does it matter? Small percentage don't matter. Anyway, so I wanted to talk about Kosi River and its flooding. Some of it has been put in outside, but anyways, how the terrain is, how the Himalayas are there, how Bihar is situated. I am showing this to the government officials in Bihar, people who should be knowing more about their own land. I am going to tell them that, and I am coming from Kanyakumari. I can't speak Hindi, I can't speak Maithili or whatever languages that they are going to speak. I don't understand at all. And from 2,000 kilometers I am going over there, and I am going to give yarn to them. So I have to imagine what kind of information I have to give, right? Like, so if I say that, so you can imagine how my behavior would be. But anyway, I'm talking about flatlands, etc. But the thing is, the way I represented this was the first time they thought about this in this way. And the moment they were like, okay, now it's not flooding just like because it's raining. Yeah, I'm having a bigger problem, a geological problem. And they began understanding all of this, like the flat topography, how alluvial fans are formed. Alluvial fans are very critical in understanding this. For example, I don't know how many of you know about alluvial fans, but like a river exits a mountain system, it starts to spread out and starts settling in sand and all those things. And the Kosi River is one of the most dynamic rivers. It has been changing course all along, and historically its course has been changing, and from east to west it has been moving. Whenever it moves, why it's moving? It has put so much sand and the place has become higher, so it's now finding another course. Now what happened was, in 1960s, however, so you can see it has 120 kilometers on the moon. But in 1960 they jailed it. They were like, river cannot move. River should stay in a same place. And they put walls on both the sides, called embankments. Constructed with civil engineers here will know it, wind dikes, how to construct it. And so began constructing wind dikes to make sure that the soil is settling in on either side. Now the problem is this: since 1960, if the river is flowing in the same direction, then what happens? It's becoming higher and higher and higher, and the embankment also has to become higher and higher. So if there is a gap in embankment, or if the embankment becomes free, it breaks open and it causes huge problem. Or the other problem is, now the river is flowing at a higher height and your land is over here. If it rains over here, where will the water go? So you can see stagnation outside embankments. Very simple Google map. I don't require big analysis, big numbers for it. You can see the elevation map. You can see, notice that Kosi River, it's all yellow over here, higher elevation, and outside green. So now what happens is that because of it, every year when it begins to rain, it goes into warning level for the entire monsoon season. I mean, why would it be like, when there is more water, once and twice you can get flood, extreme flood level. But the thing is that it will never fall down. And you can see how it has been. So in 2022, monsoon comes in, it goes out, and that's it. This is embankment failure, very recent one. Let's see how it has flooded, how many people are getting affected. So Kosi Eastern Embankment, once it failed in 2008, it created one of the worst flooding disasters in India. Millions became homeless, thousands died, and you can notice that when the embankment failure happened, the downs, because the course has changed, right? Like in another place you are having the river monitoring station. Before the water can come into itself, it has gone out. So you can see that the water level in that monitoring station has come down because the water is not coming. So I saw a paper where they used this monitoring station and they said, see, the level was not there. I mean, when Kosi was flooding, there was no water in the river. So it's not a problem of the river. Now, That's why you shouldn't go blindly with the data. The data said the station is Baswa, this data said the river is Kosi. Immediately they were like, Kosi river, this flood, at the time of flood it didn't happen, so it is something else. It was exactly the argument. And the other problem is roads and culverts. And every road is a dam. You have to imagine that. And the wider your road is, the worse the dam becomes. Because you won't construct the culverts. Box culverts, you have seen constructing it below, I do not know how many of you have seen. When I was a kid, I used to go. The nearby highway, I used to go inside it and come out. It used to be fun. Sometimes there are snakes over there. But these culverts are disappearing there. Because the bigger the roads you have, it's very costly to have culverts. So they just put a ditch on either side and they put like a common culvert somewhere else. Because of that, it has become problematic. Now, why is this important? Because the team is working on a particular wetland called Kusheshwar Asthan. And for me, I have to understand what this river and what it means. That entire thing I had done as a background research to talk about what is the cause for the wetland to exist. And is Sentinel-1, you can see which are the flooded areas. You can see that area that is Kusheshwar Asthan, that is where having lots of water. That is the wetland that these people are talking about. It's all okay, it's good. But why specifically over there? That becomes the next question. So you can see that the fan of Kosi River, which is elevated, now it's becoming a wall for water not to move on one side. So it can move only here, right? That's the only logical way that the water can move. So they have built the embankments on the other side of the river over there. So basically it's a 100 kilometers long dam. And water from the other side cannot drain to this side. So this was a recently created wetland, will be the question. So we referenced old maps. We found out there was no existence of wetland before 1960s. It was like, there's a possibility of certain small things, but it was not a massive wetland that you are seeing right now. So, and wetland has been created because of the embankments. And what we noticed is also, it is all agricultural land. People are owning land. It's not like they wanted to declare it as a wetland. I mean, people are doing agriculture over there. Can I go over there and say that, your place is a wetland? Tomorrow, what will happen? So, we began studying that. So, we began understanding the causality. This was a presentation I made to them. So, the final thing that I had to talk about was that the river needs to move out. We have to figure out some way for it. Else it's going to constantly flood the state. Second is that in your embankments, you cannot put it as walls all around. You need to have some gaps which you can control. I don't want it to be demolished overnight. Control it. Sluice gates. And third is culverts for major roads. So these are the solutions you can focus on and start putting in money. So Bihar flood and wetland, how did I come from that till the solution? Should be explained from this till the end. Only then a government officer will be able to understand. This presentation I made it very short, 15 minutes I might have taken. I explained it thrice or 4 times, the same thing over and over again, each time for 2 hours. And I had to tell them what is the problem, etc. etc. See, data, numbers, not important. Story, that is the important one. And that is what will lead to a decision making process. Now, out of these 3 decisions, what are you planning to do? That is up to them. I mean, I am not going to force a government to do it. It's a popularly elected government and it's their headache, not mine. If they are not going to do it, it's the people who voted for them should ask the question, not mine. And I can just say that this is the best thing that you can do. But that's where it goes. But anyway, thanks. I'm done with it.
Any questions to be answered?
Any questions? No.
So once you say most of these fallen, but when we see the most of the news air from DCs or something, they say it's booming, still it's gross.
Yeah.
where is this mismatch?
Who is writing those articles?
No, even the people who work on the VCs or those companies which work on the
Exactly, that's what. Who is working on these articles? That's the question, no? See, if I ask a person from BJP to write about the performance of Modi's government, what do you think would be the result? If I ask a person from Congress to write about the performance of Modi government, what will be the result? So it depends on who is writing it. So the thing is that they have a bigger voice. When the geospatial data guidelines came out, this was one question asked by a journalist to me, because I was the only one, when the guidelines came out, not when the act came out, I was the only one who was writing a criticism against it. I was a critic. My criticism was that it doesn't make data from taxpayer money to be made open in the public. It said easy. Now what is easy? Easy and cheap. What is easy and cheap? IMD thinks that it is cheap that you can sell data for crores and crores of rupees. So many organizations are there. What is cheap? Right? Like that is a big question. FRI, if you look at FRI's data policies, it's a headache. Everyone has these. It's not like they, but they didn't talk about it at all. What did they talk about? Initially, they wanted to make surveying easier. They wanted to make data collection procedures easier. If you look at all the procedures that could be made easier, it would be all required for a consultant company, a GIS consultant company. And you take the articles that are written by pro of this guidelines, it will be all these heads are investors of these consultant companies. Starting with Map My India, Atmanirbhar. They filed a case against Google. I was just mentioning to Ujaval the other day. They filed a case against Google about Google Maps being dominant or something like that. As if they will allow everyone else to grow. It's not like that. They are using these opportunities to make money. And in such a situation, they are all right positive about it. They are seeing 10 million jobs in GIS and remote sensing. I honestly don't see it. Even if it is, it's not high value. In the sense like, you can have academics using GIS. That's a different story. Only GIS person, GIS technician. It's very difficult. You can be a hydrologist who wants to use GIS and remote sensing. There's a use. But as GIS as such, spatial science as such, because how many of you will you pay for Google to give you navigation results? That's why I asked earlier about the market of it. It's not there actually. I don't see it. When people ask me like for jobs, I don't have that power actually, but people think that I have the power to give more jobs. They're like lower salary is also fun. 10,000 rupees is also fun. You know how many people are applying to these positions? It's very difficult for me to even shortlist, let alone interview. It takes so much of time. I see a lot of resources that have been, human resources that are there in the industry, and I don't see that much of a business opportunity. But everyone else is a pro. Right now don't be be a Roman when in Rome, right? Now everybody is believing it. You live with that hype, and that's it. But it's hype. That's what I was saying. How many map products will you buy for your personal reasons as an individual? How many of you are willing to buy? And how can you claim that when you are not interested to buy, how can you say that there is a market for it and people can be employed for it? Where will the money come from? How long can you take away the money from the VCs? Most of it will have difficult time in breaking. I see some. It's not like I'm completely against it. There are applications, but it's overrated, right? Amazon is using some navigation for its distribution, etc., etc. At certain point, if you look at it, a computer engineer can solve it. Only thing is they do not know latitude and longitude, and initially they will have a difficulty in understanding the projection systems. That's it. And after a half an hour or 1 day of exploration, a computer engineer can do the entire thing. So most of your market is covered that way. Only after that, probably the areas that I would think is crop yields, where you can attach it to the stock market or commodities market, or you can think of surveying, mining companies, construction company, construction companies for their larger projects. That sounds good. Beyond that, it is all overrated.
More questions? I don't have a question, but I have a different opinion. You talk great in detail about planning and related issues. So I felt that you are not very optimistic about the role of machine learning. So I personally am not I don't know machine learning or not a data scientist. But being in this domain, I work in the water resources, and I feel that machine learning has a great potential to solve the problem. For example, it could be helping in finalizing the interventions and the background work. So in countries like India, we don't have a proper database of maybe buildings or whatever. So definitely, if we send people out to carry out the survey and then get the details, it's going to be very unimaginable effort required. For example, now we have these Google Street View and other things. Maybe a machine learning model can identify the type of buildings, age of buildings, number of stories, all those details. I think it has a potential.
So in fact, what do you think is the potential? Like water resources, what is the potential? In water resources, what is the potential that you think?
Yeah, for example, for flood damages, if somebody wants to make a decision on whether to construct an embankment or not construct an embankment, so they need a cost. And the cost of, or let's say the benefit is not much. So then why would anybody go for something like that?
Is there a machine learning model for it?
Sorry?
Is there a machine learning model for this?
I don't know, but
that's the thing. I mean, my question is, it's more like that. It's a comment. What I'll say is this. See, machine learning models are reflections of what it is allowed to learn, mostly. And like I was saying, majority of these things, the ground problems are not represented in any of your data. It is not represented in the internet. There is no text around it. There is no proper research around it. What will an ML model learn?
We can train probably. We can train to identify to how many number of stories it can.
No, stories of building, I mean, that's not a flood problem, no? Like,
It is a flood problem. Because we want to identify what will be the total damage that is being caused with the flood.
See, irrespective of it, in this one only I differ a lot. Why do you need to have a costly ML algorithm? I mean, ask them to report it and send a photograph. 3 stories, this much.
I'm just thinking about the total number of databases that you need to collect.
Exactly, that's the thing. The cost you are saying is going to be huge.
Yeah, in machine learning it's going to be cheap.
Machine learning is not cheap. Machine learning is not cheap. If I want to send, say for example, Whitefield is flooded. Let's say Whitefield is flooded. I want to, there are like say 2,000 streets. I'll employ 20 people to go out and survey. Each person in the current market rate, each person for a day, they will ask 1,000 rupees. Right? So let's say I'm completing it within 10 days. 10 days into, let's say 10 people and put up 1,000 rupees into it. How much will it cost? 100,000 rupees. Right? All the information that I want I'm getting with verification, with a trained professional. No question marks. I mean, in the sense like I know what they had done or something like that. In machine learning, what happens? The programmer that you are going to hire will ask for 100,000, let alone the rest of the things.
Okay, I stand corrected. May not be cheap, but considering the requirement, for example, it could take maybe years together for people to go and survey just about one city. But if you imagine about all the cities that are being impacted by flooding in India,
I honestly don't see it. That's why I said about the budget of my hometown, 25 crore rupees. See, you can do it in Bangalore because Bangalore has 6,000 crore rupees in its 8,000 crore I think right now. I'm not sure. But that budget. Mumbai, I can say it has 30,000 crore budget, which is somewhat like like a large state itself. But most other cities don't have that money. We imagine that they are all equal. It's not. That's not available actually.
yeah, I don't know honestly about any statistics, but I'm just thinking that it has a potential.
See, anyway. But anyway, for 10 years it has been having potential.
I think the problem is also that you can solve the problem, but should you solve the problem?
That is another interesting one. That's a question.
Should you do this or not? And that requires data. I give another example, like talking about monitoring farms and things like that. And all this comes out like you can do it with satellite imagery, but just the collecting cost of satellite imagery at that resolution, it's a massive exercise. A lot of money. Then you need it every week, every day. It's just better to send a person. You get much better information. So if you had all the money in the world, you can have your own satellites and fly drones every day. Great, you can do it. Machine learning can extract that, but it's not fit for certain kinds of. So I think if you had data, machine learning is the best to say.